This is our Hummingbird session. This is the second in a series of hummingbird and pollinator workshops that we've been hosting. And so it's exciting to see the interest in this topic grow. This is the only session where we will be allowing people to be in the room so that you can interact directly with questions after each speaker. We're also taking questions online through Facebook's live streaming and also on birddaylive.com. So feel free to send us your questions. We'll be tracking those. If you want to ask questions in this room, please put those in the chat box and we'll funnel those to the speakers as we go. So thank you again for joining this session. We have a great lineup for you. I'm going to just talk a little bit about the program that we coordinate with Environment for the Americas. I'm with Environment for the Americas, and we coordinate the Western Hummingbird Partnership, which is a partnership of a number of groups and organizations from Canada to Mexico who are concerned about the conservation of Western migratory hummingbirds. We do have an advisory committee with representatives from each country who help to guide us in our work. And of course, hummingbirds are our little superheroes. They travel long distances. They are the smallest birds in the world. The things that they do are amazing. The fastest wing beats, the fastest heartbeats, you name it, they've got it. But there are many concerns about them. And one is, for example, the rufous hummingbird, which has experienced declines of up to 60% or more since the 60s and 70s. And so why these birds are declining is a real concern to us. Other projects that the Western Hummingbird Partnership is working on is looking at some of the impacts of, for example, ski areas or ski lifts on hummingbirds. This is a new issue that we're just learning about and studying to see if we need to do more. Also looking at floral nectar resources at different parts of the migratory flyway for hummingbirds. And so we'll be working for a year with Saguaro National Park, looking at floral resources, their availability, and how we can help hummingbirds as they cross between our countries. Also, the impacts or benefits of fire. How does fire help and how can it be not beneficial to hummingbirds? What do we need to do with fire and how can we manage it for the benefit of hummingbirds? So a lot of projects that we're working on, including all over, again, Canada, the US, and Mexico. And you'll be hearing from some of our partners during this presentation about their work and also from our advisory committee members. So thank you very much for joining us. Again, I'm going to ask those of you in the room to turn off your cameras until it's your turn to talk. I'm going to ask our first speaker, Bill Hilton, to turn on his camera so that I can introduce him. And Bill works on ruby-throated hummingbirds. He was twice named the South Carolina Science Teacher of the Year, which I didn't know. Bill, congratulations. And he was also cited as one of the 50 best brains in science. So Bill, congratulations. And thank you so much for being on with us today. I'm going to turn it over to you. Oops, I'm not hearing you yet, Bill. So let me get you unmuted.
Okay.
There you are.
All right, thanks. Appreciate the opportunity to speak today. Although I'm not in the West, I'm still interested in hummingbirds that are out there. And I want to talk today about one from the East. So I want to go straight to screen share. And is it up? Do we have a test screen?
Yes, it is. You are good.
Okay, great. All right, that's not really my topic right there. But this is ruby-throated hummingbirds. And they don't have Superman on their chest, but I think they're the ultimate hummingbird species. So ruby-throated hummingbirds, part of Operation Ruby Throat, the Hummingbird Project, which I operate as principal investigator with help in the tropics from Ernesto M. Carmen. And Operation Ruby Throat is part of Hilton Pond Center for Piedmont Natural History, which is a small nonprofit in York, South Carolina, just over the border from Charlotte, North Carolina. Two websites you might be interested in, hiltonpond.org and rubythroat.org, both of which are operated by the center. And the first one's about all kinds of nature, the second one about hummingbirds in particular. So Hilton Pond Center is actually pretty small. It's only an 11-acre site, but it's still the most active year-round bird banding station in the Carolinas. And since 1982, now 40th year we're in. Hit the wrong button. Since 1982, 127 species banded on the property and 73,664 individual birds, which is a lot of birds. And of those, 653 have been ruby-throated hummingbirds. Here's a thumb-sized bird. That's a lot of hummingbirds, about a shoebox full, because they're not very big, I guess. Banding hummingbirds is something I do, and you're going to hear more about that from another speaker a little later. But just briefly, hummingbird bands are very different than other bird bands. They come on sheets that have to be cut into strips and then turned into individual bands. And the bands themselves are quite small. We store them on diaper pins temporarily before we use them. And then we put them on the bird's leg. So here we have a hummingbird with very long talons. And here's a hummingbird that I banded at Hilton Pond. And I just might mention that all the birds I band there get temporary green dye on the throat. And I do that as a way of tracking birds locally. It wears off after a few months. So this is the object of our affection for right now. This is the ruby-throated hummingbird. RTHU is the 4-letter code. This is an adult male with the bright red gorget in Costa Rica. It's called Colibri garganta ruby. And scientifically, Archilochus colubris. So ruby-throated hummingbirds really are the ultimate hummingbirds. They have the greatest distribution of any of the 340 plus hummingbird species. Population estimates are up to 34 million. That would be at the end of the breeding season in the fall. In summer, they're found in 38 US states and in Canada all the way over to Alberta and perhaps British Columbia. The winter range is Mexico and all 7 countries in Central America, but not South America. They don't get past Panama. And historically, they have spent year-round time in the Gulf Coast of Texas and South Florida. And more through the years, particularly in the last 20 years or so, they're now found some places inland and as far north as Virginia. In fact, 9 years ago, I was out in the Outer Banks of North Carolina in January, in the middle of the winter, and I banded 9 ruby throats, which is unprecedented. And ruby throats are cold weather wimps, so it's likely that they are a good example of you know what, global warming. So ruby-throated hummingbirds are the only hummers that breed here in the eastern United States, very different than out west where you might have 15 species. But there's no breeding in Central America or Mexico for ruby throats. And here we have an adult female sitting on her nest made of lichens and spider webs. But don't be confused in the summertime because young males may look like females. They don't have a bright red throat, may have some streaking, may have 1 or 2 or more red feathers on the throat. So young males masquerade as females. So people ask, when do hummingbirds get here when they're ruby throats? Well, here's a little map, and you can see that along about the 1st of March, they're starting to show up in the Gulf Coast. They get to Hilton Pond just before April 1st, but they don't get into northern Canada, or southern Canada rather, where they actually do breed until on into May. So I know specifically how long it takes them to get here at Hilton Pond. The earliest record I have is 27 March. That's happened in 4 different years. Then there's a little bit of a increase, and then there's a lull, and then there's another increase, which I think may be a second wave of hummingbirds on the middle of May. And then around the 1st of July, the young birds start to fledge, and there's a huge increase in the number of hummingbirds up until about the 15th of September, when the bottom really drops out. And by the 18th of October, I've never had a ruby-throated hummingbird. So this shows the results of 38 years of work. You can see that 6,653 ruby throats. Some years I've had not as many, but in the last 10 or 20 years or so, I've been over 200 almost every year. And in 2016, I got to 373, an incredibly high number. This year, I'm at 9 right now, as of 255 today. So about 11% of my ruby throats that were banded here come back in at least one later year. You might say, well, that's not very many, but when I tell you that maybe 50, 60, 70%, even 80% of all the young ruby throats produced this year will die before next year due to migration perils, predators, disease, getting lost. All sorts of things can happen, including flying in picture windows and actually getting killed by feral cats. That's another topic we'll talk about some other time. But these birds are showing site fidelity on the breeding grounds. And I catch the same birds year after year here at Hilton Pond after they've been to the tropics. Amazing for a bird the size of your thumb with a brain the size of a green pea. My returns are pretty good. This big year, 62, was the year after I had that gangbuster year in 2016. So far this year, I've got 3 coming back, but I expect to get up to a good many. Now, you notice both of my charts showed a red line that went up, which indicates to me that ruby-throated hummingbirds are not in the same perilous situation as rufous hummingbirds. They seem to be doing very well, and I'm getting more and more every year at Hilton Pond. So if I look out my window in August or July, this is what I might see at my feeders. If I look out there in February or January, I see this. And so I taught high school biology and college biology for many years, and my students often ask questions. And one of the questions they might ask me, where do the hummingbirds go, Dr. Hilton? And my answer would be, like a scientist, I don't know. Well, not exactly. However, being an educator, I say, I think I know how to find out. And that's where Operation Ruby Throat really got started, trying to figure out what hummingbirds are doing, where they're going, and how. So migrational paths of ruby-throated hummingbirds were originally thought to be like this. People thought that all the eastern ruby-throats went out to Florida before they went across to the Yucatan Peninsula. But when I was in grad school in Minnesota, it didn't make sense to me that those birds from Alberta and Minnesota would fly all the way across the Great Plains to go to Florida. But the only way you're going to know what they're doing, you can't put radio transmitters on them quite yet, but you can put bands on their legs and hope that they're found on the other end. So let me show you one case history of one of my birds. Involves 2 states, South Carolina, where I am, and Georgia next door. And on the 6th of October, this would be fall migration in 1991, a woman in Atlanta saw a green-throated hummingbird at her feeder and contacted Bob Sargent, a hummingbird bander who has passed away recently, who came and caught the bird, read the band number. It was 54512. He contacted me. I told him it was a young male, and I had banded it just 10 days earlier at Hilton Pond. And here it was 170 miles away. That's just phenomenal, because that was the very first time in history the ruby throat recaptured and released more than 10 miles away from its original banding site was found by somebody else. So that was our first indication that hummingbirds really do migrate. And why was this bird in Atlanta? Well, my joke is, well, Atlanta's a hub and you have to fly there before you go anyplace else anywhere. But was this bird going to Florida, where people thought they all went? And I think not. This bird was going in a southwesterly direction. So I actually have 4 birds now that have been southbound from Hilton Pond. One of them, the bird is just showed you from Atlanta, 2 from Alabama, Thomaston and Mobile, and another one from Cameron, Louisiana on the Texas border. And were these birds going to Florida? I think not. And incidentally, these birds were all green color marked, and they were all spotted by citizen scientists just like you. So if you're south of York in the fall, be looking for green-throated hummingbirds. If you live north of me this spring and summer, be looking for that green. So question number 1 again is, where do the hummingbirds go, Dr. Hilton? And the answer now is, I do know, at least for 4 of them. But those are good data points. That's what helps us understand birds better. Question number 2 for my students. Where do the hummingbirds go when yours were seen in the southeast, Dr. Hilton? Well, we have now new migrational paths for ruby-throated hummingbirds of Milton Pond. They're not doing this, we don't think. My birds are lollygagging across the Gulf Coast states and ending up maybe over there in Texas. So question number 3, where did the hummingbirds go and fall from the Gulf Coast, Dr. Hilton? Answer number 3 is, that's a very tough question. So we now have new migrational paths. They may be doing this. More likely they're doing this, either going from, say, Louisiana, perhaps from Rockport, Texas, but why not go overland through Mexico? All these are possibilities, but you notice that all of them have question marks. And that's because when we look at ruby-throated hummingbirds that are banded, like this bird, 450,000 of them have been banded in 100 years in the US and Canada. And finally, just a year or so ago, a hummingbird banded in New Jersey was recaptured in Nicaragua, the only southbound ruby throat ever found in the tropics on the non-breeding grounds. So question number 4 then is, where do the hummingbirds go when they leave the neotropics and come back north, Dr. Hilton? And the answer is, well, I don't know. It's just a really tough question. And that's why Operation Ruby Throat started taking neotropical field trips. So I got on an airplane at 20,000 feet, flying where hummingbirds are flying just over the waves, going across the Gulf to Central America. And prior to December 2004, there have been very few ruby throats banded south of the US and Canada. 29 in Mexico, 14 in Costa Rica, 2 in Belize, 1 in Honduras, only 46 total in the neotropics. So Operation Ruby Throat ended up going to Costa Rica first. They went to Costa Rica and flew into Liberia over in Guanacaste province to a little town called Cañas Dulces. And Cañas Dulces is important because this grows there. This plant is Aloe Vera in Spanish, I believe, sometimes called the burn plant because it's used to treat birds, but it's grown commercially and it flowers in early February, but it's not native. It came from Africa and it's grown now in Costa Rica and elsewhere. And what's interesting is it has a lot of flowers on it. So in 2004, 14 of my citizen scientists, nicknamed the Pioneers, went to Guanacaste province for our first expedition. And in the aloe vera, we put up mist nets and we saw immature male ruby throats coming to these tubular yellow flowers. And with the mist nets, we would catch ruby-throated hummingbirds for banding and tracking. So we observed ruby throats and learned a lot about their behavior and other attributes, but most importantly, for our long-term goals, in June of 2008, a man in Baxley, Georgia, that was working at an auto dealership went into the big truck bay and he found a hummingbird that was caught in spider webs, and he removed the webs and looked at the bird's leg, and it had a band on its leg. Unfortunately, the bird died. It was a female ruby throat. And he sent me the band, and I looked it up in my data sheets, and C51599 that was found in Baxley, Georgia, had been banded on the 28th of January, just 6 months previously, in the aloe vera fields of Costa Rica. And here it was, 6 months later, 1,500 miles north of where we banded it. And we were very excited about this particular bird because it was the very first and still only migratory hummingbird of any species banded in the tropics and later encountered in North America on the breeding grounds. So our results from Guanacaste, where the aloe grows, was we had 12 expeditions with citizen scientists. We had 798 banded ruby throats and had 9 returns in a later year, showing site fidelity. And 1 foreign encounter, that bird that showed up in Georgia up north. We also went to a new site in Costa Rica, and at that location in Ujaraz, which is in the Central Valley, we, instead of looking at aloe vera, we're looking at this. This is a vast field of terraces of chayote, And chayote is a squash that hangs down from these terraces, and the workers go through and pick it. But it also has lots of flowers, both male and female flowers that are there year round that attract a lot of hummingbirds. So it's a native species that is cultivated. The flowers are very fragrant and also have a lot of nectar. We had 8 expeditions to Uharas so far, 531 ruby throats banded, much more profitable to go there hummingbird wise. We've had 4 returns in a later year, but none of the birds from Uharas have been found up north. We have one other study site that has been reasonably productive in Belize. And Belize, as you know, is on the Yucatan Peninsula. And so it happens to be on the way in northbound migration. We went to a place called Crooked Tree. And at Crooked Tree, we were looking for this tree. And this happens to be something called cashew. And it has little red flowers that really attract hummingbirds. Now, interestingly, here's the cashew pear or the cashew apple and the cashew fruit, the nut itself. This is a non-native. It was brought in from Brazil and it's cultivated and it flowers in late February and March, right when the ruby throats are moving north. So at this location, we used mist nets out in the mist and we used traps to catch birds at our lodge. And we ended up with 7 expeditions there, including some college groups from Keystone College in Pennsylvania. We banded 149 ruby throats, 1 later year return, but no foreign encounters. So we now have 30 neotropical trips with citizen scientists, 20 to Costa Rica and 1 by myself solo, 7 to Belize, 1 to Guatemala, 1 by myself, 2 to Nicaragua, 1 to El Salvador, 1 to Honduras. And you'll see those other countries are not nearly as productive as far as hummingbirds are concerned. So we now have 250 alumni, and many of those have been on more than 1 trip with me, which is a lot of fun. So these are the actual numbers that we have from Hilton Pond, from the neotropics. Costa Rica West, 798, Costa Rica East, 531, Belize, Guatemala, Nicaragua, El Salvador, Honduras, and that's a grand total of 1,540 ruby throats. And you remember originally only 46 had been banded in the tropics. So that's the result of our work over the last 10 years or so. Now numbers are neat, but other things we've learned are also important. The site fidelity thing I think is really important because we demonstrate all the time site fidelity here at Hilton Pond, but this was the first time we knew they were site faithful in other countries in the neotropics. We also studied wing molt sequence and timing, which I can't talk about today. They were also territorial down there, just like they are up north. We have that 1 northbound migration point from Georgia. And we studied feeding a little bit, looking at opportunistic feeding by hummingbirds and also at native plant foraging and whether ruby throats might be pollinators or not. So to bring in the pollination component, these are my top 10 neotropical hummingbird plants. And if you look at them, these are multicolored and various shapes. And 3 of them happen to be cultivated crops down there. But if you look at the top 10 native ruby-throated hummingbird plants here in the US and Canada, well, it's a little different because up here, they're all red or pink or something similar, and they're all tubular. So it's very interesting that the wintering plants are very different than the breeding season plants. So hummingbirds apparently all pollinators. Here's pollen on the throat, pollen on the bill, pollen on the forehead. And that pollen on the forehead, I guarantee you, means that bird has been visiting this plant, which is trumpet creeper, Campsis radicans, one of the big Noniaceae, and it's the ultimate native hummingbird flower for the ultimate ruby-throated hummingbird. This plant grows everywhere in the east where the hummingbird breeds. These are the reproductive structures, stigmas and pistil. They're probably pollinated a little bit by insects, but ruby throats are certainly the major pollinator of trumpet creeper. And trumpet creeper may be the major food source for ruby-throated hummingbirds. You remember this chart from earlier, 15 May is when the first nestlings start to appear. But it's also when the first trumpet creeper blooms. And the 15th of September is when migration is really hitting the peak, but it's also when trumpet creeper stops blooming. So I think that trumpet creeper, which exists from the middle of May through migration, is really the ultimate hummingbird plant. And it's a very important, a co-evolutionary thing between ruby throats and trumpet creeper that's nicely demonstrated by my work. So although some hummers are highly adapted to specific flowers, like this sickle bill here on a heliconia, ruby throats are really opportunists and generals. And that's why they're so successful, I think. But they end up being important pollinators of native species within their breeding range, especially trumpet creeper, but also bee balm, cardinal flower, and lots of other red tubular flowers. And we don't know the importance of ruby throats as pollinators in the tropical wintering grounds. So that's a big opportunity for somebody to do some work in the field. And ruby-throated hummingbirds migration is still a big mystery for us. And all that boils down to one thing, and that's that we need to conduct more ruby-throat studies in the neotropics and more in the US and Canada, because ruby-throated hummingbirds really are the ultimate hummingbird species. That's it for me. Thanks for the opportunity.
Thank you, Bill. It's great to have you. For any of you who are in the room, and also those of you who might be listening out on the airways on Facebook or birddaylive.com, please feel free to put your questions in. I have a question for you here from, let's see, from Oli Rojas from Durango, Mexico. And he says, I heard somewhere that the hummingbird feeders up north were contributing to fewer hummingbirds down here in Mexico. How true is this?
Well, I think it certainly is not true for ruby-throated hummingbirds. As I mentioned earlier, they don't tolerate cold very well. And virtually all the ruby-throats do bail out of the US and Canada and end up going to the tropics. So I think feeders have no impact upon migration at all. Migration is probably keyed by day length in the US and Canada. And when the days get short enough, the ruby-throats leave, whether their feeders up or not. So I think it's probably a negligible effect.
All right. Thank you so much, Bill. We're going to move on to our next presenter and appreciate your coming on. I don't know if you're aware, Bill, but the ruby-throated hummingbird is a focal species for World Migratory Bird Day this year. So We're so excited to have you on to share information about it. Our next speaker is coming from quite a long ways away. This is Mary Reynolds. Mary Reynolds is an Irish gardener, a landscape designer, an author, a public activist, and she's also known for being the youngest contestant to win a gold medal at the Chelsea Flower Show. She currently works as an author, designer, environmentalist, and she published her first book, which I happen to have, and we got just so that we could make it. Ooh, I don't know if you can see it with my background. There we go. Nope. Maybe not. Anyway, it's called The Garden Awakening. It's a beautiful book. And if you're interested in getting it, you can go to environmentfortheamericas.org and you can purchase it on our website. We were really excited to be able to get that. She is, what else can I say about you? You are a landscape designer, and your work is just so incredible and relevant no matter where you live. So welcome, Mary. Thanks for being here today.
Thanks, Susan. It's lovely to be here. I'm going to share my screen, so just get this moving now. You guys see this? I'm not sure you can. Okay, I'm going to try and...
Not quite yet.
Not quite yet. Okay, for some reason it's not letting me screen it. Just bear with me, please.
Sure.
I'm going to join from a different computer. So if you wouldn't mind allowing me in again, excuse me.
You should be able to get in. It's open to multiple participants. So
okay, that's fine. Now, let me see. Okay. So here we go. Right, I'm clicking to join, so bear with me.
yeah, I don't think it's coming in. I'm not sure why.
I'm going to leave this and I'm going to come back in a different computer. Apologies, but I think it's the easiest thing to do.
Okay, maybe what I'll do, Mary, is we'll go to the next speaker.
Yes.
And then we'll come back to you. Okay, that sounds good. Thank you so much. We'll see you in just a minute. All right, so I'm going to go next then to Coro Arismendi. Coro, welcome. to
Hello,
World
how are you?
Hummingbird Day Live. Coro has done so much work in birds and bird conservation and including hummingbirds. So I'm going to turn it over to you, Coro.
Okay. I'm going to try to share my
Your screen. And I believe for our translators, for everyone, this session will be in Spanish. However, it will be translated. Coro will present in Spanish. Her slides are in English, but you can also catch her on birddaylive.com where we have translation. Melinda, I think it looks like we're having some trouble with sharing screens.
Yes, I cannot. I think now I can do it.
There we go.
You
Great.
see? Yes. Are
Yay,
you-
perfect. Thank you.
Okay, thank you. So I think you are seeing the last one. No, the first one.
Yes, we are seeing the last one.
Yes.
Now you're on the
Now
first
you are
one.
seeing, and you are seeing in the whole. Yes. Now. Okay.
Yes, perfect.
Ok. Bueno, entonces, muchas gracias por haberme invitado a este
Okay,
simposio.
thank you so much for inviting me to this event. I'm going to tell you a little bit about what we have done in my team regarding hummingbird gardens. Hummingbirds are animals that depend on nectar. Mostly 90% of their food intake comes from floral nectar. They have a high metabolic requirements, and so they're feeding themselves throughout the day with short periods of rest. And for this reason, their biology is always linked to the blooming of the flowers they visit. Also, they can live in the highest of the mountains or at sea level. And they also can live in human settlements that are part of this height gradient. Urban environments are characterized for being hostile for animals in general. Why? Because they usually feed themselves with flowers or plants, and these plants are substituted, like we can see in this slide, by buildings and roads. We don't have many parks, although there are some, but it's difficult for animals to find flowers in urban settlements. The growth of cities in countries like Mexico and throughout the world is something that has been speeding up in the last couple of years. Here we have a graph which is only for Mexico from the 1900. We only had 32 cities back then, and nowadays we have 384 cities. And some cities like Mexico City with over 20 million people, rural population has decreased and urban population has increased in about 50%. Worldwide, the situation is not that different. We have seen that over time, urban population from the 1900s to 2021, we see that the volume of people living in cities is increasing more and more than those that live out in rural areas. I tried to recreate what happened to Mexico City, a big city where you can see the volcanoes that surround us. This is a valley surrounded by mountains, surrounded by two big volcanoes, the Popocatépetl and Iztaccíhuatl, and you can see how this city has grown in a huge way before this beautiful landscape that is now covered in buildings. Here we can see how Mexico City has grown, specifically between 1910 and the year 2000. As you can see, in 1910 is this red little dot that we have in the central area. Then 1930s, 1950s, and by 2000s, it's everything that we can see, plus the part of Mexico State. And this is divided because it's divided in Mexico City And it also considers as a metropolitan area some municipalities from Mexico State. So we have seen that these have continued to grow. On the right side of the screen, and in 1980, we had 14 million people. By 2017, 21 million people, and I think now there are about 24 million people. So the city continues to grow. The city is also becoming grayer. Here you can see the street, a very famous street, the Paseo de la Reforma. We can see it in 8070 and in 2020, how all the surroundings of the road have been populated by buildings and is less green every year, even though it still keeps a couple of trees. So in cities like these, the habitat for pollinators and specifically for hummingbirds has changed drastically. It's an environment full with cement buildings with only a couple of spots where you're able to find green areas where hummingbirds can still exist. And well, hummingbirds are present throughout the Americas. We have 330 species, of which 58 species are in the northern part of America, Mexico, Canada, and the US. In Mexico, we have 58 species because of the migration topic that we have been discussing, and most of the species travel to Canada and the US to breed. Hummingbirds are very charismatic. People love hummingbirds. They want to have them close. They think of them as animals that bring good luck, bring good wishes, that bring love. And so people like to have them around. How to attract hummingbirds into our backyard then, to our gardens? There are two main ways. One is to use feeders, and the other one is to plant a garden that is also going to help us restore the habitat. So feeders, artificial feeders. These are a way of having access to the visits of hummingbirds, especially when you live in a city where you don't have enough room to have a garden. These feeders, we've seen that they can be a way of increasing the number of hummingbirds in cities. Actually, it is documented in a couple of cities that when you have more feeders, then you see more individuals and more species of hummingbirds. But here the question is, are they good for the birds or not? They have been extensively used in the US and Canada, and in the tropics is something that has only been around for a couple of years, maybe 10, 15 years. And then what is the answer? Yes. If feeders are positive, negative, or they don't have any effect on the hummingbirds. So we did carry out many studies to try to answer these questions. And here in the map, you can see in the star where Mexico City is located. It's a city that it's 2,400 meters over sea level, and it has about 20 to 25 million people. It used to be a lake, a basin surrounded, well, that was colonized. And this colonization started to grow and grow until we basically lost all of the lake, although we do have a big water belt in the southern part of Mexico City. But hummingbirds in Mexico City, apparently, we have more and more individuals. And we can spot a couple of species. And what is the reason? It may be that there's more habitat, or are we using more and more feeders? And so we are creating an artificial habitat for hummingbirds created by the human race to which hummingbirds can arrive. So are they good or are they bad? We did an experiment in an ecological park in the southern part of Mexico City. We implemented feeders and we saw what was the response. When we did implement feeder, we saw a higher activity of hummingbirds. There are more individuals, but then we said, okay, then let's find out if there is any effect in the plants that hummingbirds usually visit, because there are reports that when there are a lot of flowers, then hummingbirds forget about feeders. So we tried two species the Mexican salvia, which is the purple, and adelanta, the red one. And we saw that the flowers, that when the feeders were near the flowers, then the hummingbirds did not visit the flowers as often. So these flowers, we were also measuring the amount of seeds produced by the flowers when they were nearby to the feeder and when they were not. And we realized that in both cases, the plants produced more seeds when they were not near the feeders than when they were near. But in Salvia fulgens, it was different. The number of seeds produced. But in the case of the Mexican salvia, this was not the case because we didn't realize that for the Mexican salvia or the salvia mexicana, we didn't realize that we were implementing the feeders, but the number didn't change because there was a specific beetle that works as a pollinator for these flowers. So these flowers were not affected and they produced the same number of seeds because of that. So what is the alternative? If we see that if we have native flowers, they could have negative effects in pollination when we implement feeders for the hummingbirds. So the alternative is to create gardens for them if we have the space and the resources, even though you can start with a single pot to huge gardens. So we started to work with this project and we did the entire description of what you need to have a hummingbird garden. And you only need a little piece of land in which you can put flowers that are visited by hummingbirds. If we can create just a tiny space with different levels where the hummingbirds can fly as they naturally do, that's great. If we can use endemic species, it's better because one, they are adapted to the rain regime, and so it becomes less expensive, and also they're already used to the weather, so they survive the cold. So we started to promote hummingbird conservation through Hummingbird Gardens, and we started in different areas of the city. The first one that I'm going to talk about is in Tlanepantla, the northern part of Mexico City, and the others are in the southern part. We started with a garden in one of the campuses of the UNAM. Right now, I am the head of the faculty, and we implemented the first hummingbird garden in Mexico. We planted flowers for hummingbirds, and we did very small descriptions of the most common hummingbirds, and then we started to propagate this idea to try to implement gardens like these in all high schools and higher education institutions in Mexico City. This is in Tlahuac. These are highly populated areas. And this is how you see Tlahuac. It's full of bridges, full of cement. And we did a beautiful project with a planter for hummingbirds that the kids from the high school built themselves. And this is still at the institution. And so this was expanded to the IEMs, which is another institution in Tlalpan as well. And then another campus decided to adopt the idea in Iztacalco of the same institution. And it's worth mentioning that the high school students were the ones that took care of planting the plants, and they are the ones observing and taking care of the gardens. We planted endemic species of plants. We planted plants that we grew in a greenhouse, most of them, and we carried out a lot of dissemination activities in which the kids and the students and their teachers were the stars of the project. They're the ones that helped us promote this project, which was great for the students in this sense. We also worked with Kudu kindergarten with kids, and so we took them to the monitoring station that we have at La Cantera in the university campus of UNAM in the southern part of Mexico City, where we have been banding hummingbirds for about 10 years. We took kids there to get to know the project, to get to know the hummingbirds. And then we also worked with elderly nursery homes in which we implemented feeders, because people that are in this nursery home, sometimes they don't have a good sight, so it is easier for them to spot them with the feeders than in the gardens. So we used feeders so they could relate to the species and see how to attract them. We also started to work a couple of years ago with the Mexico City government in habitat restoration, like this one in the national channel. Here's a picture back from the 1900s. Ships could go through there. And this was before starting the restoration. There was no water in the channel, and now we have carried out a very successful restoration of the area. And now we have the DuPont hummingbird that is naturally coming back to visit these areas because we have been planting flowers and gardens there. So now it's a place where you can go bird watching, and the neighbors enjoy that area as well, especially in during the pandemic. We created 2 handbooks to make your own garden. The one from the Mexican government, Gardens for Life, Jardines para la Vida. We advised them on this book, and then we made another one to disseminate the information to the general public, and it's called Gardens for Pollinators. We are also working in parks of the city. This park is called Coyotes, and they created a garden specifically for hummingbirds, and they're working in partnership with a group of women to take care of the gardens. This was before the pandemic, and I don't know the current state, but I think they can be easily recovered. We also work with the National Association for the Pollinators Protection, and we have the goal of creating 1 million gardens for hummingbirds, and we created tools that were necessary, like the books of hummingbirds of North America and Mexico, and we also created brochures in which we summarize the information only of the hummingbirds that you can find in Mexico City. And here we have the most common species, and these materials are aimed for younger children. We've identified 256 gardens. Most of them are in Mexico City, although we do have a couple of them in other parts of the country. These are registered in a website that we created for such purpose, and you can see it here. You can register your garden there, and we also uploaded it to the Naturalist Project of Conavio, which is the Ministry of Conservation and Environment of Mexico, and we have records of hummingbirds nesting and raising their chicks in hummingbird gardens. We are analyzing this data to be able to make a publication about it or publish an article. So with that, I would like to thank you for listening to this presentation. Thank you.
Thank you so much, Coro. I appreciate that. I'm gonna go back to English, and I sorry, I put a mistake in here for everyone who needs translation. All you need to do is go to the interpretation button and choose the translation, and you'll be put right in there. But when you're out of this session, you can also go to Bird Day Live for any other Bird Day Live presentations. Coro, you touched on this for just a moment about the effect of feeders on hummingbirds. And we still have another question. And so maybe you can talk a little bit more about this. A question from Samuel in Mexico, and he wants to know if hummingbird feeders change the migratory route of hummingbirds, or do we know that?
Yo no creo que ha cambiado la ruta migratoria. Yo creo que
I don't think that it has changed their route, their flyway. I do think that the feeders are giving them a bigger habitat than the one they had before, because an average feeder, like the one you can find in any pet shop, is about 2,500 flowers for a hummingbird. So if they are pollinating habitats like Mexico City, I have no question that there are many hummingbirds there due to the feeders. And we can easily see that in the book that we published about hummingbirds of Mexico and North America. We can see how There are hummingbirds that did not visit the western part of the United States before, and now we can see a higher number of species there. So I think it is changing the patterns of distribution because we have more habitat for them. And as I always say, if you use the feeders responsibly and you clean them, then they shouldn't be a problem for hummingbirds. The problem is that a lot of people forget about them, and especially in the tropics, the nectar gets fermented very quickly, so it may cause a problem, or it may have bacteria associated to hummingbirds, and we've seen hummingbirds that do get sick from feeders. So we need to be careful. We need to clean them regularly. We need to put fresh nectar, and we cannot let any other animal drink from there, because then they get filled with bacteria and the hummingbirds could get sick, just like if you drank water that is not
I know a lot of people are talking about changes in
pure.
the hummingbird
And
range and
I know
population, and of course, maybe we don't know what is actually contributing to that. As Coro mentioned, it is really important to keep your hummingbird feeders clean. If that water gets hot, it ferments, it can actually kill hummingbirds. I guess it causes a paralysis of the tongue, which they need to, insert into the nectar feeder, into flowers, so that the tongue can't retract and bring in that hummingbird, that floral nectar. So please, if you live in a hot place, and I know where I live in Colorado, it gets extremely hot, clean out your feeders regularly to help protect hummingbirds. I have one more question I'm going to give you, Coro, and this is from Benita Luna. She asks, how can she get seeds or plants of native flowers? This is a great question. Is there a database of native flowers for Mexico?
No hay una base de datos. Tenemos algunos viveros que están produciendo.
there is no database. We do have greenhouses that focus on producing plants like Paraíso, and we've tried to disseminate the information as much as possible. So usually where you can get plants in Mexico, like Xochimilco, which is a huge place of greenhouses, they are already selling plants specifically for hummingbirds. We've been advising them with the help of the Mexican government. And I think that this is something that everyone has to do in different places in Mexico. I've been working with a guide of the endemic plant species of Mexico City and the surrounding areas with my team, but I think that this is something that everyone should do in all of the cities. So we have what you have in the United States, the planting guides that the National Pollinator Campaign has. I think, well, I would love to have those planting guides for all the different regions in Mexico, but we need to get to work because I don't think I can do that myself.
Planting guides for different regions in the Western United States. And at the same time, we actually lack knowledge of hummingbird floral preferences, especially maybe during migration. And I think Bill brought that up. It's a good point that what they are foraging on in Latin America can be quite different from what they're foraging on where he sees them in the United States. And we need to learn more about those floral preferences if we're going to help them. So thank you very much, Cora. We appreciate your being on today. And I'm going to bring back Mary Reynolds now. Mary, I'm hoping that we can get your presentation up. Mary also talks about gardens, but more from a landscape perspective. So if you missed my introduction to Mary, she's the youngest winner of the Chelsea Garden Show, but also an activist and a real passionate advocate for native gardening. So Mary, let's give that another try.
Okay, apologies for that. Gosh. Here we go.
Yay, it's working. Thank you.
I
see it.
You guys can see it okay? Great.
Yes, we can. Thank you so much.
Thank you for having me, Susan. Thank you so much.
Wonderful to have you.
We are about to talk a little bit about a movement I started a couple of years ago called We Are The Ark. And We Are The Ark started one day when I was sitting at my desk. I've been working as a landscape designer all over the world for many years, and I've gradually been talking myself out of a job. And the final kind of nail in the coffin came when this particular story happened. So I was sitting looking out my window, designing a garden at my desk, and I saw a fox run past, and it was winter time and it was daytime, and chasing the fox were two hares, which would normally be the other way around. So that was unusual. And then a little while later, I noticed a hedgehog creeping along, scuttling along in the shade of the hedgerow, going in the same direction. And it reminded me of the stories of Noah's Ark when I was a kid. So I thought, this is very strange. And I went out of my house and I walked in the direction that they were coming from. And I live in rural Ireland, and I walked to the end of my lane, and across the road, which is it's a very narrow road, it's only wide enough for one car, and across the road there used to be this thicket of a field which was full of thorny plants. It was impenetrable, full of blackthorn and whitethorn, lots of different native plants, and you couldn't get into it. But somebody had got planning permission to build a house at the top of the field, and they had gone in with a digger and cleared it out in minutes to make a garden, which is something that many people do. And it's something I had done myself so many times without any thought for any of the creatures that called it home. So I was kind of horrified, and I went back inside and started researching, how nature was actually coping. And I realized that these creatures, these wild creatures that make up the web of life on the earth, that we are very much, supposed to be here to take care of, that web of life is collapsing because these creatures don't have many places left to go. Agricultural land is becoming more and more chemically destroyed. The habitats are being removed constantly to make sure there's more land for the monocultures of crops, and there's no sanctuary or shelter for the creatures we're sharing the planet with, or not sharing, as the case may be. So they try and go into our gardens, but our gardens are filled with non-native plants. And they are structured in such a way to create an image of what we see as being beautiful. And true nature is not like this. And our patches of the planet have become outdoor rooms, basically, with no room for anybody at the inn other than our own creative idea of what is beautiful or easy to maintain. So all of these gardens are extremely unhelpful to creatures looking for sanctuary or food. They can be, our idea of what is beautiful has been shifted, has changed. And actually we travel all over the world to visit on places of untouched natural beauty, and then we come home and create these gardens which really are very unnatural. In Ireland and in many places in the world, we have very little woodland left. We have 2% of our country is still covered in native woodland. It used to be 80%. Now there's another 9%, which is covered in monocultures of spruce, which are non-native trees, and nothing lives underneath them. Nothing lives within them. They're chemically treated constantly to deal with the pests, and because there's no balance. So this is a situation which happens all over the world, and we keep removing our trees, which removes our habitats for creatures. This is an image of just a typical shot from anywhere in Ireland looking down on the land, and people think it looks beautiful and green, but it's actually a green desert. There's very little life left there for them. Like most of our gardens, they contain alien plants, which we bring in because we see them as being pretty or useful or tasty. But a lot of them have escaped from our gardens and become invasive species outside of their own ecosystem. These invasive species have no checks or balances, which they would naturally have in their own world, and they have taken over and destroyed ecosystems, which has become a major part of the problem. We also keep breaking up our tiny little wild places. They're becoming smaller and smaller and smaller because of islandization. We keep crisscrossing them with roads, taking them for urban sprawl for ourselves. We have to start considering the lives we're sharing on this planet. So you guys are talking about hummingbirds, which is really fascinating. It was amazing to listen to those two people. we have such an immense variety of birds in the world, and they have such an important ecological role to play. They maintain the populations of insects, they keep everything in balance, they distribute plants, they move plants around, they basically create our landscapes of plants because they're so involved in the distribution of those native plants. They are very much involved in rodent control and, you know, anything rotting bodies. Birds are part of, you know, some of the larger birds are part of removing the carcasses of dead animals. They're a very important part of ecology. But the important thing to remember, and I know you've touched on this a lot already, is that native plants are what we need to support our birds. Native plants are the foundation stone of any system. And birds generally feed, and I know hummingbirds are slightly different, but birds generally feed their young on 80% larvae and about 20% of spiders. And the thing about larvae is that they have 90% of insects still only eat the plants that they've evolved alongside in the local food web. And our larvae don't really have places to the butterflies, moths, and other insects don't really have places to reproduce. So people forget that they keep the wildlife gardening narrative asks people to bring in all these showy flowers, and they forget that actually, although the pollinators are attracted to these really showy flowers, what happens as a result of that is that the native plants, which are not showy a lot of the time, in different parts of the world they are obviously, but in Ireland in particular, the native plants are disregarded by the pollinators because they're attracted to the more wildlife gardening narrative plants and the non-natives, and then they don't get a chance. The native plants don't get a chance to set seed, and the relationships between insects and your native plants are the foundation stone of all ecosystems. So what I'm asking people to do in our arks is to give at least half of any land they have under their care back to nature so that she can take care of all her creatures. If they can't give half of their gardens back, to at least give some of it back, as much of it as they can spare. And what I mean by that is, it's a very simple thing. It's when you're aware of the pressure that our environment is under, when you're aware of the collapse of nature around us, it is very hard to know what one person can do to help. But what I'm asking people to do is to step up and allow nature to recover. And there's 5,000 weed seeds in every square foot of soil, and those native weed seeds are locally adapted alongside the local insects, and that's the reboot that a local ecosystem needs more than anything. In urban areas, this is not going to happen. The seeds might not be there because of damage to soil, but those native weed seeds are the pioneer plants. They're the ones we want to allow to come out, because they're the ones that have very intricate relationships with restoring health to the soil, supporting insects to reproduce, and developing a multifaceted ecosystem in as many layers as you can manage in whatever piece of land you have. So, you know, a lot of people, this movement which I started has taken off all over the world. That we have arks. We have arks about 1,500 acres in America, down to window boxes in Norway, and people are putting tiny little signs in their window boxes, which is really cute. And the signs are really important, because you put up a sign saying this is an ark, with the website underneath, wearetheark.org, which allows people to go and research what's happening in their neighbor's garden, because most of the time people find it really hard to let their gardens get messy or wild, but there's no life in a tidy garden. And when they put up a sign, and everything is homemade, you make it out of whatever you can, saying this is an ark, with the website, it explains away why this is the way it is, and it allows people to be proud of their spaces rather than feeling ashamed of the messiness that they may, you know, feel a little bit worried about presenting to their neighbors. And then their neighbors can get inspired, and then it can spread. And the hope is that we create a patchwork quilt of healed land that spreads its way around the earth and makes a huge difference. And the wonderful thing about it is that as one person, when you are aware of how difficult the situation is and how close we are to collapsing, you know, our ecosystems, it gives us such hope when you realize how quickly nature can recover if we just support her to do that. So it's very similar to rewilding in many ways, but we call it arking because we're dealing with tiny patches of islands. And obviously in rewilding, you would bring back as many of you would reinstate the predators from the top down, the keystone species. And in arking, you can't really do that, obviously. So, you know, you kind of have to become all those, become the wolf, become the deer, become, you know, whatever creatures are missing from your system. So in your garden, what that means, if you translate that in an ark, you would try and create as many different layers of ecosystem maturity as you can, all with native plants, preferably with the plants that emerge from the earth. It's the, you know, if you have land that isn't damaged, and then, you know, you bring in cuttings and seeds from plants, native plants, within a 10 to 20 mile diameter distance, because even the local evolutionary adaptations are very specific. So it's good to keep it as local as possible, as well as keeping it native. We have this wonderful ark in Ireland now, which we set up, myself and Claire and Joe, friends of mine in North Wexford. And we do all these extra things which support wildlife in their gardens or in our arks. So one of them is dead wood. We create dead hedges, piles of twigs and prunings. We leave dead wood where it is, like a standing live oak supports over 500 species, but a standing dead oak tree, for example, will support thousands of creatures, because dead wood is full of life. It's full of insect life. And if it's safe to leave standing dead wood, please do. Otherwise, leave it on the ground where you can, because it will rot down slowly and feed a lot of creatures as it goes. Also, leave the leaves if you can on the ground. Leave the twigs, leave anything that falls. It's a very important part of the larvae development process. And it's like nature's winter blanket for the ground. It's full of life, and we keep tidying everything away. And those leaf blowers, which people use a lot in landscaping, they destroy the whole ecosystem. They burn so many little lives. And if you have to remove leaves from pathways or sidewalks, just try and use a brush or a rake. Very simple. And you know, this is nature's way of recycling nutrients as well. Lighting is another very important part of having an ark, and being part of the solution rather than being part of the problem. And the lighting in our arks is so important, because it's one of the major problems, causes of ecosystem collapse, is the blue and white LED lights, which are now commonly used everywhere in street lighting and in garden lighting. And it blinds our nighttime pollinators, which are so important. Moths. I don't know if you remember when I was young, you open a window at nighttime and the room would fill with moths, and that you just don't see that anymore. Certainly not here. Some places maybe it still is there, which is a really good sign. But by removing lighting from your spaces outside, if you can just put on sensor lighting, which only comes on when you move, when you need it, and then let darkness prevail in between if you can. If you have lighting and you cannot remove it, if you could put a filter to make the lighting amber, because that disturbs them a lot less than the white and blue ones. Having a water feature of any kind is going to be of a major benefit. It's one of the massive ways of supporting a huge amount of wildlife. It's very hard for wildlife to find clean sources of water these days. So even a bowl sunk into your ground, filled with rainwater, and maybe one of those solar powered sprinklers that keeps the water clean, maybe an oxygenating plant and a ramp so that creatures can get in and out and they don't drown is a major, huge help. It's so simple. In our ark in Wexford, we started off, these are some of the creatures that have come to live there. Hedgehogs are one of my favorites. So we started off with 4 acres in Clare and Joe's place, which is called the Irish Forest Garden online. And you can find them on Instagram. It's really wonderful to follow them. Their place is just so full of life now. But this is before they started. It was basically a few acres of grass, which was a horse paddock. And after a couple of years, they've developed it into this incredible wildlife sanctuary. And you can see here that it's full of things like thistles and docks and all the things that a gardener would normally die if they saw these in their space. I'm not sure what time it is. How am I doing? So thistles and docks are now not part. They're a very much important part of our lives, because butterflies just love them, and the amount of creatures that live there and create babies on them, on their leaves, are amazing. So it has become this real haven of life very, very quickly, by allowing it to recover, by allowing the weed seed bank to emerge, by stopping it being mowed all the time, allowing the native grasses to come out, by removing the non-native plants, there's a lot of there's a big food forest here as well, which is on its 6th year now, I think, and that is an incredibly abundant paradise for humans and birds alike. This is their pond, which they put in, I think it was a year and a half ago, or about that, maybe even 2 years ago now. And it was in clay, so it doesn't need a liner. It's just a hole dug in the ground, and you compact the clay, and then it fills up with rainwater. So there's some before and after pictures. And just to remind you that, you know, the pollinators have very specific relationships with insects. So we have this idea of nature, which we're starting to lose. There's this wonderful concept called shifting baseline syndrome. And it's where children these days, or a lot of adults actually, don't really know what nature looks like. They often think that the access they have to nature is their gardens or parks, or, you know, really adapted landscapes. And so it's called shifting baseline syndrome. And it means that for every new generation of people that comes along, what we see as a degraded, damaged landscape, they will see as natural. And within a few generations, we've lost our understanding of the abundance that used to be in nature. We've forgotten that the sky used to go dark overhead from the quantities of migrating birds passing over. You know, that swarms of butterflies used to block out the sun. You know, when we were driving along when you were young, and you'd come home and the windscreen of the car would be covered in insects, and now they're gone, you know, in many times. But what happens when you create an ark is quite amazing, really. The amount of life that comes back. There was nothing living in this particular piece of land, and now it's full of owls and hedgehogs, and the bird life is phenomenal, and the insect life is just spectacular. And the amount of creatures that have come to find sanctuary in this 4 acres of life, really within a dead agricultural landscape, is phenomenal. It's almost like a bell was ringing throughout the county, and they all came almost overnight. It became this incredible life and full of life. And this is some pictures of the forest garden, which is full of food plants as well. So I think then it might be nice to take some questions. I have some really nice pictures of some of the pictures that people send from their own arks all over the world, and they make their signs out of all sorts of weird and wonderful things. And we have a Facebook group which is called We Are The Ark, and so many people it's like our main rule is kindness, and so it's a wonderful group because ARK stands for Acts of Restorative Kindness to the Earth. So we have these wonderful kind of a community of people which share all the creatures that have come back to live in their little patches of this planet. So I think that's enough, Susan, and maybe
Yes,
I
thank
can't.
you so much, Mary. That's just wonderful. And I'm gonna put another plug in for your book, which is called The Garden Awakening. We do have it here at Environment for the Americas. If you want to get that, it really is just a beautiful book. I haven't gotten a chance to read it yet because we just got it in, but I'm so excited about it. We do have a question from the airways, and one of them is, how do you convince people, that like you mentioned, people are so accustomed to having these tidy gardens. How do you convince someone to bring some wild into their garden?
Well, it's quite interesting actually, because it's because they don't really have to do anything. It doesn't really cost anything to take a section of your garden and kind of give it back, and if you want to be part of the solution rather than the problem, you can just take a small section of any land you have and we have these steps on the website for developing it into an ark. But what happens is that people notice very quickly that little corner of their space is full of creatures, it's full of insects, it's full of life, and very, very quickly they see that the rest of it is a lost opportunity, because your heart expands to include all the creatures that come to share your patch of this planet. It's like your family expands. So you want it it's like a natural process of kindness. You see, okay, you stop looking at land as something that's pretty, and you start looking at it as something, what can I do to help the creatures that live here with me? We do say to people to grow your own food as much as you can, to step outside of the industrial farming system, or to support local organic producers as much as you can, because that's one of the main problems that's killing everything on the planet is industrial farming and fishing. So you can't, there's a lady there saying, can you visit these art gardens? Well, you can certainly look at them. We have a map on the website and they're all over the world. I don't know, mostly people don't put their arks on the map because they like to be private, but I think there's nearly 800 arks on the map, and we have almost 20,000 acres on the map of ark which has been restored, but there's an awful lot more than that in reality. People keep seeing ark signs popping up in all sorts of weird and wonderful places in the world, and it's a lovely thing, because it's not, it belongs to everybody. It's an idea, and it belongs to everybody. And the idea of putting up a sign saying this is an ark, and then kind of giving it back to nature and understanding that we're only just sharing this planet.
Thank you so much, Mary. I'm going to go look at that site and see where the art gardens are. Maybe there's one near me, but we appreciate your time. We appreciate it's at nighttime for Mary. So we appreciate your coming on late in your evening.
No,
Thank you. Thank you very much. It's been a pleasure.
Take care.
Our next speaker is Umberto Berlanga, and Umberto and Coro actually have created a hummingbird guide, and that he's going to share some information about. Umberto is the leader of NABSE in Mexico and works with Conabio. Welcome, Umberto, and thank you so much for joining us today.
Hola, Susan, y hola a todos y todas. Muchas
Hello,
gracias por
Susan. Hello, everyone. Thank you very much for the invitation. Let me share my screen. Sure.
It's up.
Okay.
Muy bien.
Bueno,
Okay.
a mí me pidieron que hablara
I was asked to talk about the hummingbirds in Mexico.
de esta presentación.
I prepare this presentation with Coyotes Mendy. I wanted to thank the organizers and all the participants on today's panel. Thank you very much, and congratulations for your presentations. They have been beautiful as well as. Well, first of all, as you mentioned, Susan, I'm going to talk about this book that we published in 2014. Coyotes Mendy and myself, called The Hummingbirds in Mexico and North America. Why is it called Hummingbirds of Mexico and North America? Well, because all the species that we have from Mexico up north reside in Mexico. All the species of hummingbirds that we can find in Canada and the United States are shared with Mexico. That is the reason why this is called like that. This is a bilingual book. This was the first issue, and it has been reprinted twice. Approximately 10,000 books have been sold throughout Mexico in the past year. A little bit later, we published Conavio this poster. Posters you can see here on the right with all the species of hummingbirds. At that point, we were not separating the species, but those are well known or endemic in Mexico and has been circulating a lot in schools and in every type of environments. People really, really like hummingbirds, and it has been very well published and shared. Both the book and the poster can be purchased in Conavio. You can purchase it online, but also sold in many bookstores in Mexico. I already mentioned that the book is bilingual, right? Yeah, it's in both English and Spanish. It is very important to mention as well that the book, we have a PDF version downloadable directly in this website, Biblioteca Conavio. You can actually Google it, Biblioteca Conavio Hummingbirds of Mexico, and this is free to download. We're actually preparing a second issue. Hopefully it will be released this year if the pandemic allows it, and it is corrected and preached. Just to give you an idea of the contents of the book, we have a technical data sheet of all the species in Mexico of hummingbirds. As you can see, the top part is in Spanish, the bottom part is in English. And for the majority of the species, we give you illustrations created by Marco Pineda, a biologist, alongside with a distribution map that includes, well, these maps are modified from Hollywood Web, information from eBird. The green dots outside of the regular distribution of these homobees, in this case, the well, this is influencing, this is a black sheen hummingbird. I wanted to include this book because there are not so many publications of hummingbirds in Mexico, and this book in particular is very interesting. It is a personal experience of this group of people, Jose Pérez, Rocío Meneses, and Ricardo Flores. They actually went around Mexico to photograph all the hummingbirds in Mexico. They have them. As you know, the biological diversity increases as we approach the equator, or all the way around, it decreases as we move farther from the equator. This species are only found in the American continent. We're talking about 340 species, and go from Alaska to the Patagonian. As Cora mentioned, we have 58 species in Mexico, and practically we can find them in any type of ecosystem, including urban environments. 17 species can be found in the United States and Canada, and all of them can be found in Mexico. Just to give you an idea, of the map, we have Colombia, that by its own has 150 species of hummingbirds. It is pretty much the paradise for the hummingbirds. I created a series of this is a little table. Mexico is not super diverse, but we have a very important part of hummingbirds because we have a great deal of diversification, which is just give you an idea of taxonomic diversity, let me tell you that we have 40 species of hummingbirds with 300 types. But we also have these different groups as coquettes, hummingbirds. We have different emeralds, sovereign. We have a different species over here, so you can take a look. We have different, very, very different 14 species out of this species are endemic. 1 of 4 are located in Mexico. The first 3 that we can see, I put them in red just to show you with the illustrations of the book. If you can see in the map of this species that we can see in my with my mouse, we can see a distribution in the coast of the Pacific. We also have a distribution of the Gulf and Central America. This species was used, it was considered just a single species, and very, very little while ago, it was divided into 2 different species. This is divided in different populations that can be found in the western part of Mexico. These are considered single species. And this is the different species over here, another endemic species. So we can give you an idea. Has a very strange distribution here in the northern part of the Yucatan Peninsula and another population right here in Veracruz. That maybe we can conduct some genetic studies here. And well, the crown jewel, the rarest species in Mexico, which is the Atoyac coquette, which is the short-crested coquette, and all the worldwide population is just in this single park over here, and it is very restricted for just one single species of bird. Well, continuing with the endemic species, we have also 2 main categories that are very different: the semi-endemic and quasi-endemic species. Out of those 58 species are 2 quasi-endemic. What does this mean? That that one portion of the year, the whole population is in Mexico and the other part isn't. For example, those that are semi-endemic are in red, and the quasi-endemic are species that most of the time and most of the distribution in the world is located in Mexico. Let me give you a couple of, for example, Achilotus alejandri, which is a black-chinned hummingbird. We can see here in the map. You can see over here the distribution that it is actually reproducing up here in the north, and the hibernation area is right here in blue. This is the transit area, and we can also see but this is semi-endemic, and part of the year is in Mexico, all the population. Quasi-endemic, for instance, over here, Pampa rufa, that it is found mainly in Mexico, and its distribution goes a little bit further south here in Guatemala. But more than 90% of its distribution is in Chiapas and a little piece of Oaxaca and Veracruz. It's a very beautiful species. 47 species. I'm talking about residents. We also have a small variety of situations. 47 out of the 58 species in Mexico are pretty much resident throughout the whole year. You can see it here in the purple portion of the map. Those species, it doesn't mean that they don't have local or altitude movements, but they do not migrate in terms of height or altitude. 47 of these species are residents. The whole year we have a different species over here. The blue-throat hummingbird and the H. constante we can see on the western Sierra Madre, the eastern Sierra Madre, and in the plateau, the Mexican plateau. 5 species are mainly migratory species in winter. These are pretty much the species that my previous speakers spoke. For example, the ruby-throated hummingbird. and the Sassin hummingbird, which are actually reproduced in the north part in the country, and they spend the winter in the south. And the migratory of summer are mainly summer species like Lucifer HP, the Lucifer hummingbird. Now, how are our hummingbirds doing in terms of their endangerment categories? Where is the name? We're going to talk about it a little bit.
Se encuentran en peligro de extinción para la legislación.
4 species are endangered for the Mexican law. 8 species are threatened. 6 species are under the protection, and 39 are without category. They're not endangered. We consider different names of the different species here, which are the main species that we can find. Now, in terms of international nature preservation categories, only these 5 species have a category of the UICN. The short-crested coquette, which is a critical, it is in critical danger. The Mexican sheartail is in danger. The wood nymph, Mexican wood nymph, is vulnerable, as well as the white-tailed hummingbird. And another endemic species. One of the main characteristics of the most endangered species in Mexico is that all of these are endemic, which means there are more danger. For the UICN, 53 of the species that we can find in Mexico are not endangered or not severe danger. Now, in terms of vulnerability, there was a study that was conducted by Canada and the United States in the last decade, when we evaluated different criteria associated to the main features and characteristics of the species that are right here in this column. In the column to the right, we assigned values from 5 to 20. So that way, 19 or 20 is the highest value of vulnerability that a species can find. And now, talking about the different categories of the norm of the UICN, in addition of the endemic column, you can also check over here that many of these assessments match. For example, the short-crested coquette and the Mexican norm for the UICN is in critical danger, is an endemic species, and has a vulnerability value of 19. And you can actually make an analysis each of the species according to the data that we can find here. So the most endangered or species, or the species with the critical danger in Mexico, are of this group, and where we can find the IUCN category, the Mexican official norm. It's like the endangered species or in the United States. All of them have very, very small populations, which are intrinsically vulnerable. This is only a reference. The population is way, way lower than 50,000 individuals. Many of them have a decreasing trend. They have very, very small distribution area, and normally are associated with ecosystems or vegetations are also endangered. This population they have been endangered for many different habitats. All of them have very high vulnerability values. There are species that need to be addressed in Mexico. Since we're talking about migratory birds, it is very important to talk about the resident species in Mexico. Just to give you a little summary about this, many of them were already mentioned. Having a limited distribution or restricted distribution, of course, represents vulnerability that is from the species. If it is, for example, distributed in a very small area, this, of course, might cause the extinction. The same thing happens with reduced population. Not only do they have a restricted distribution, but the population is scarce. And if the habitat and the number of individuals of this population are reduced, then those are very vulnerable species. So I think that's why they are very, very much endangered. One of the main factors that are bringing this species into this vulnerability status are the destruction and fragmentation of their habitat. Climate change, of course, we all know. We don't know the effects, but we don't know how, at what degree it's affecting the migratory species and other man-made problems, like, for example, crashing against buildings, windows, and also, of course, illegal commerce. It is not general, but there's somehow a little bit of illegal commerce. I will say that these are the main threats. Maybe later Susan maybe can tell us how the ski resorts affect hummingbirds. Maybe here in this chart we can find 4 microendemic species in Mexico. Euphoreus polycerca, which is the short-crested coquette, have the nymph as well. And I want you to see the small distribution area of this species, that any change in their surroundings, of course, becomes a very important threat. We can find them in this category. I also wanted to show you this chart coming from the study that we conducted with Florida. If you want to come down to Mexico and watch hummingbird, we can give you these protected natural areas that we have here, as well, and some other important areas for birds presentation. This study was conducted to see how well represented the species of hummingbirds were presented on the natural protected areas. I'm not going to talk about it right now, but it's the jewel crown is the Elocote Mountains in Chiapas with 32 species, but the other ones over here, Sierra de Atoyac, Tehuantlan, Manantlan, all of them are very well preserved and protected areas, but they have different altitudes, which is very important, and creates different layers with different type of vegetation, which of course creates conditions for different species of hummingbirds to interact. For example, in the Ocote Mountains, half of the species, or more than half of the species, are located in one single area. We can see different species over here as well. Now, in terms of hummingbird watching, which is something that is not only for hummingbirds, but it has become really popular, thanks to the efforts of many people, also thanks to the development of many tools, online tools, or so we in Conavio developed in collaboration with many organizations like Ornithology and Hummingbird Society. We have developed some tools and online tools about birds to support the people that are interested in this. For example, the people in charge of natural protected areas, people who build Hummingbird Gardens. Well, this also gives some tools such as eBird that you can download in your phone or your computer. In Mexico, this tool is called A Ver Aves, the iNaturalist platform, which has also helped to promote wildlife. Technology that came out from Cornell, which is Merlin Bird ID, which is an app that allows you and that helps you to identify different species depending on where you live. You can download specific packages of a region or a country. On the website AvesMX, which is knowledge base, shared knowledge base here in Mexico, that we keep constantly updated. You can find the full list of birds in Mexico and a lot of information about any species. It has to do, it is connected with the eBird, Birds of the World, and many other platforms from other organizations that we're working for. You can access avismx.org. It's on the Conavio website. It is a little bit intuitive and minimalist, but the Enciclovida, that is not only for birds, but for any other species of any animals or plants or even fungus, and a series of projects that we have been promoted for several years in Mexico, like the Community Monitoring Bird Watching Network and the Urban Action Program, with a lot of volunteers that allow us to create activities such as this one, like ornithology, and recently they have expanded to Central and South America. So these platforms and these programs are becoming more popular, and they have helped the citizenship, the citizens not only to get involved, but also to be engaged on the preservation of hummingbirds and every bird in their habitats in Mexico and everywhere. So that's it for me. Thank you very much for your attention. And if you have any questions, please let me know.
Thank you, Humberto. Thank you so much for that. We only have time for one question, and it looks like a lot of people are asking, where can they find information about Mexico's hummingbirds, including the book and other resources about pollinators?
Well, you can find all that information in the website of Conavio. It's conavio.gov.mx, or simply you can Google it and type in the name of the book, and you will find it in the website.
Okay,
Conavio.
great. We'll pass that along too. Humberto, thank you so much. We'll probably have more questions at the end so whoever from the presenter side can stay online, and we'll get some of those questions back to you. Thanks, Humberto. Next, I'm going to bring up Christine Shepard, and Christine is with is a scientist with Climate Change Canada, and she has focused her work on chemicals and their impacts on hummingbirds. Hi, Christine. She's also an advisory committee member of the Western Hummingbird Partnership. So I'm going to turn that over to you, Christine. Thank you.
Thanks very much, Susan. And I'm going to share screen. Where are we? Oh my gosh. There we are.
There you go.
I can just get to move this around. Sorry. Trying to get this so that it's full screen, but your screen is in the way. Just a second.
There you go.
How's that?
That's good. That's perfect.
Hey, thanks very much for the invitation, and really enjoyed hearing the earlier talks. Look forward to the next ones. And I just want to start off with something that might be familiar to many of you who have hummingbird feeders. And if there isn't, keep watching them closely, because what you're going to see is a hummingbird peeing here. And that might just look like pee to you, but to scientists, that is golden. And it's been really useful to us in our research on pesticides and hummingbird exposures. But as you can see, here's Dr. Hilton got a picture from, maybe that's even his finger. See hummingbird fecal pellets and hummingbird cloacal fluid. But we're going to use the scientific expressions during this talk as pee and poop. So this sort of thing is not familiar to you if you like other types of birds and you see the white uric acid kind of poop that they produce. But hummingbirds are constantly processing liquids from the nectar, and so they're producing something that looks a lot like human urine. And in this fecal pellets, about a pinhead size, there's a lot of information in there that we can derive. And I'm going to talk about pesticides, but one of my collaborators, Alison Moran, from Rocky Point Bird Observatory and the Hummingbird Project, published this paper recently, collecting poop from the edge of Rufous hummingbird nests. And it's a great non-invasive way to determine what the birds are bringing back to their young. And I guess, long story short, hummingbirds in this part of the world, which is in Canada, in BC, they really depend on soft-bodied flies. And another example of utilizing the urine here, the cloacal fluid, is Sarah Hebert, and you can measure corticosterone, which is an indicator of stress hormone, to tell you about what hummingbirds are experiencing. And so in order to collect our samples, we have the hummingbird in a wrap like this, which we're going to band them and do some measurements. And while they're in the wrap, we're able to use a pipette or a little vial to just non-invasively collect those samples. And up until very recently, in this work that we initiated with Allison, no one had ever measured pesticides in hummingbirds before. And even myself, as an ecotoxicologist in the field for decades now, it never really crossed my mind that hummingbirds could really be readily exposed to pesticides, or how we would even measure it, being such a small-bodied animal. But our chemists at Environment and Climate Change Canada, Franz Mazeneuve and her colleagues, were able to work out a method using a mass spectrometer to measure pesticides in just 300 microliters of hummingbird pee. And to put that in perspective, 50 microliters is about one drop, like I showed you on the last slide. And most hummingbirds, especially rufous hummingbirds, they tend to, this is a rufous female here, they tend to produce, less urine per sample, maybe 5 to 20 microliters. And Anna's hummingbirds often would produce something like that tiny drop you saw, maybe 50 microliters. So there's, even though they're both hummingbirds, and we think, oh, they're so similar from the outside, physiologically, they can be quite different inside in terms of processing the nectar that they feed on. So you're probably wondering what these compounds are here: thiamethoxam, imidacloprid, clethoanidin. And they are neonicotinoid insecticides. And these are the top 3 compounds that are used globally as neonicotinoid insecticides. And these types of insecticides have been introduced in the early 1990s and gaining prominence in terms of their use throughout the world since then. So now they're the top selling insecticide. And later on, I'll explain why and how they're why they were introduced to replace other insecticides. But the work that we did was to look at these compounds and some others, primarily because in Canada, Europe, United States, neonicotinoids are being reviewed in terms of their use. So we want to get more information about potential exposure. We did this work in British Columbia, and I'll show you a few more maps. And we also did some sampling of bumblebees and bees, which I won't talk about today, to look at both our invertebrate and our vertebrate pollinators. And the samples that we analyzed were a combination of Anna's and Rufous hummingbirds, looking at, in order to get a combined sample for each individual site, because most birds don't produce 300 microliters of urine, so that's the minimum that our chemists can analyze for, which is still very small. We would pool our samples per site. And what we found was in a site for the Fraser River Valley, which is one of the largest rivers in the country. And also, if you've ever been to Vancouver, that's the river that's flowing into the state of Georgia. And there's a agricultural valley associated with it. And these birds here had much higher concentrations than they had on Vancouver Island, where we had reference sites where there was no agriculture. And we're specifically interested in the bird's exposure for those that are living in or mostly just near blueberry fields, primarily because this is a cash crop that's greatly expanding in the Fraser Valley, and they use insecticides to deal with various pests, especially aphids, which carry a scorch virus that actually can kill the plants. So we also collected the fecal pellets, and as you can imagine, different compounds tend to bind to organic things like feces versus what would be in the urine, something much more water soluble. And so the fecal pellets are telling us something different. And one of the main compounds that we detected, not only in the Fraser Valley, but also over in Vancouver Island, was this compound called piperonyl butoxide. And as it says on the slide here, it's not a pesticide, but it's a compound that's mixed with pesticides that inhibit liver enzymes, mainly targeted in vertebrates, but it also inhibits liver enzymes in vertebrates. And it's designed to be present to increase the toxicity of insecticides. And it's primarily combined with synthetic pyrethroids, which are also an insecticide. They're still widely used in agriculture and domestic use. But this is a compound that binds more to organics. And you could see that we're detecting them both in the birds in Fraser Valley and Vancouver Island. So the way that we designed this study and ultimately determined that birds that are living closer to blueberry fields are more highly exposed, as we had a variety of sites here. Here's Vancouver City, and here's the Fraser River, and all up this valley here is a lot of agriculture. And here's over Vancouver Island. We had our reference sites here. We also had reference sites that were more than 1 kilometer from the blueberry fields. We found the concentrations highest birds living near blueberry fields, but we also detected these pesticides all in birds all throughout the valley, except at the highest altitude site, which is at 23 kilometers from the nearest blueberry field. So that was the only site so far that we haven't found any pesticides. So even though there's a gradient, the birds are still exposed. And you're wondering how we collect these samples. I showed you that the sort of micro situation where once we have the bird in hand, they're in a wrap and we collect their urine or their poop. But we have these traps that are called haul traps, and you can see them. They're hung around the feeder, and they have a drape on them, and then they have a fishing line. And when the birds are adapted to the feeders, once you put the trap on, when they want to feed, they come in, they fly in there, and then you're able to collect them by hand from underneath this drape. I like this technique because it means that the bird doesn't actually get caught in a net. It's just flying around inside. And you can see here that this is one of our sites that's close to a blueberry field. One of the important aspects of the work that we found is that the birds aren't just exposed when the blueberries are in bloom. It's not like the birds are going just in the fields and getting exposed. We're finding them chronically exposed before the plants are in bloom and well after that. Our more recent studies, we continue to find the neonicotinoids, but we're also finding some compounds that are being introduced to replace the neonicotinoids. And this compound here, fluoropiridifurone, which is also known and sold under the product name Savantal Prime. It's what they call the butanaloid, and it's also systemic. I'll come back to that, but it has a very similar mode of action as the neonicotinoids. And this study that we published was the first to measure this compound in wildlife. We also found it in honeybee nectar in our studies. and it's just been introduced into the market. It's purported to be less toxic to bees than the neonics, but we're also detecting it at higher concentrations in the bees and the birds than we did with some of the neonics. So we're continuing on our work, and I was really interested to see this paper published by Emily Graves and one of our speakers later in the session here, Lisa Tell, out of California. And in 2019, they did something that I think was super novel, which was to take the carcasses from rehabbers. So these are birds that have died for whatever reason, and utilize them for further scientific purposes. And what they did was rinse the feathers first with a compound that would absorb pesticides if they're on the birds, and look at whether or not pesticides were on the feather rinse aids, and then also analyze the body tissues after the pesticides have been removed from the feathers. And this is really novel, and most people don't do this when they're looking at pesticides in birds. They often look at blood plasma, other tissues of dead birds, for example, liver. But to look at it on the feathers is really interesting to me. And it also indicates that there's another way that the birds can be exposed, which is potentially through drift of the pesticides being sprayed, and that these compounds would stay on the birds, and then they could be further exposed by preening off the feathers. And what they found was that a lot of the same compounds, and you'll see the list here, were detected in the feathers and also the body tissues of the neonics, but they also found some other compounds, carbaryl and malathion, which fall into other categories, the carbamates and the organophosphates. So hummingbirds are far more exposed to pesticides than we ever imagined prior to 2015. So what is the relevance of neonics to birds? It's only recently that we're starting to understand that these compounds could have some direct toxicity to birds. In relation to the study that we did, Simon English and Ken Welch and others at University of Toronto, in collaboration with us, did a follow-up study and actually exposed this compound, imidacloprid, to ruby-throated hummingbirds in captivity at concentrations that are representative of their environmental exposure that we know here out in the West. And it found that just with a 3-day exposure, we could suppress the respiration of the ruby-throated hummingbirds quite quickly. We were following on some of the work that was done by there's a powder that's sticky on that seed plant, and then when pests attack, a lot of times seed-eating birds will consume these, and their appetite, their body mass, and can change their feeling physiology and delay migration in these birds. And even though we haven't measured that with hummingbirds, our short-term study indicates that, yeah, these birds are susceptible, and potentially, especially for migratory hummingbirds, this could be really relevant. There's a lot of other studies now that have come out showing that exposure can cause a lot of other effects in birds. Because when these compounds were introduced to the market, they were pitched as being very low toxicity to vertebrates, but high toxicity to pest insects. And then, in general speaking, insecticides of any kind are a bit of a problem for birds because birds are depending on aquatic insects, so they're vertebrates. So birds that eat insects are experiencing a food removal situation wherever insecticides are being used. And just want to point out that, and I'll come back to this, is that hummingbirds eat lots of insects, as Allison found, in terms of one of their main protein sources for their young. So let me tell you a little bit about neonicotinoids. So the organochlorine compounds, the DDTs that you might be familiar with, the organophosphates, the pyrethrins, all of these compounds that have been introduced before the neonics, they're what I would call contact insecticides. And they had a variety of environmental problems, but primarily they hit the bug and they kill the bug. So when you spray it, you have to come in contact with it in order to kill it. And of course, some of these compounds were phased out because of being highly persistent. DDT has a half-life of 43 years, for example. Organophosphates and carbamates, they're highly neurotoxic to not only insects, but to people and other animals. But the neonicotinoids were introduced because they're systemic insecticides. So they start out, as I mentioned, as a seed treatment. In many cases, this is the primary way that they're actually applied on the landscape. And as the seed grows, this compound will go in all parts of the plant. So, but ultimately, it's not only in the plant, but it can be in the dust, especially in certain situations where the seeds are in dry soil. The dust from the soil can pick this up. They are relatively persistent. They are water soluble, and they are neurotoxic. And that's one of the reasons why they're called the new nicotinoids, is that they actually have a similar mechanism in terms of their toxicity to nicotine. And we show this as well here because that's one of the ways that the compounds are also applied, especially in fruit growing areas. So this gives you a sense of where the neonics can end up. So these are examples of sorts of seed treatments. Birds might actually consume the treated seeds a lot of times when tractors are applying the seeds, or the seed drillers. When they turn, a lot of times seeds are lost. And so there can be an actual dump of seeds in some fields where birds can pick them up. But they could also be sometimes feeding on seeds that are planted in the ground. Once the compounds are in the ground, they can migrate into water, soil, nectar, sap, and also into insects. And for hummingbirds, as I mentioned, they're eating insects, they're eating nectar, and there's another way that they can be exposed, which is to be consuming sap that are from sap wells that are produced by sap suckers, because these neonics and these other new systemic insecticides are actually applied in forests as well for certain types of pests and can permeate the trees. So there's a lot of different routes where hummingbirds can be exposed, as well as the work by the Graves paper that indicates that, perhaps drift as well from spray events. So I just want to finish by saying that hummingbirds aren't alone in terms of their exposure to these compounds. And there's a number of papers now showing all sorts of different types of birds that you wouldn't expect to necessarily be exposed. They're not necessarily seed eaters, but even some raptors and owls can be exposed as well, and we have detectable levels in their tissues. So I'll leave it there for now. And if people have questions, I hope I can answer them. Thank you.
Thank you, Christine. That's always fascinating and worrisome, of course. We have time again for one question. We're running about 15 minutes over maybe. And the question is, again, similar to the question for Mary about, how do we convince people about tidy gardening? Well, people also seem to be very accustomed to using chemicals in their yards and for insects. It also maybe plays into part of that tidy, that tidy aspect of agriculture and gardening. Do you have any suggestions for how we present information about the impacts of these chemicals on birds and even our own health?
Yeah, well, I first wanted to say that, I'm mostly focused on agriculture in this, and I mentioned forestry in this talk, but, we also have to take some responsibility for ourselves, because there's a lot of use of pesticides in domestic situations. They're used in greenhouses as well. We like to have those beautiful flowers come home and they look pristine. Well, there's a reason that they look pristine. It usually means that there's been some use of chemicals on them. Furthermore, imidacloprid is a common treatment for fleas on dogs. But having said that, I think that some of the messages that people have said this so far, I think one of the main things is for your own food and benefits for community, try to utilize your community shared agriculture if you can access it. It's organic, and you're supporting your local farmers, not an industrial complex of farmers. You're talking about a local farming group. So I think that that's one of the most important things. Obviously, in your own garden, you've got to be able to tolerate some level of insect or slug uses. Planting, there's a lot of good plants, especially here in the West Coast, that are actually slug resistant. Utilizing things like herbicides to get rid of invasive plants, not necessarily from your garden, but I think in a habitat restoration scenario, sometimes just digging them out is not going to work. But these can be used in spot spraying in a very controlled situation, as opposed to just broad scale spraying. This is a sort of thing that I think we need to try to avoid in the future, because these compounds aren't just staying on the crop, they are moving into the areas off the crop as well.
Thank you. And thank you so much for that work. It's critical. And I think it's going to be we're going to learn so much more as we add to the number of threats that hummingbirds face. This
Thanks
is
again.
definitely one of them. Thank you, Christine. And next we're going to go to Tana Beasley. Tana comes to us from Arkansas, where she runs a hummingbird banding station. And Tana, are you there?
There you go.
Yes, I am.
Thank you. And we don't even need to share a screen. We're going to share you full, huh?
That's right. Well, we've had a lot of wonderful information and a lot of statistics and so on. So we're going to go to the practical part. We are going to be banding hummingbird for you live. And as all of you know, when you do something with live stuff in front of an audience, anything can happen. So we'll try to control that. We've got the cages set up outside. Hummingbirds are being cooperative today, and they're happy to get in there, and I guess they want to have a band or something. But before we go out to catch the little hummingbirds to bring them in, I want to go ahead and set things up. Now, this means that I'm going to go ahead and get my band ready to go. And these little bands are so tiny, and we also frequently have the question of, is this heavy enough to impede the flight of the hummingbird? Actually, if you took 5,500 bands, you could put those in an envelope and send it with a first class stamp. So they weigh practically nothing. So very tiny. Each band has a letter and 5 numbers on it. And so we'll start out with getting our band ready to go. And we'll take it off. Now, right now, the band is in a circle. So we're going to have to open it up a little bit to be able to slide that over the little leg of the hummingbird. So this is a little tapestry needle. And I'll just go ahead and slide it up almost to the eye. So now I've got it open. And a special pair of pliers is what we'll be using to put the band on. There's a little rubber band here that will put enough pressure, it will hold the band where it's supposed to be, and I can slide that right on the little leg of the little hummingbird. And when I close it, no matter, since there is a circle there, the leg and the band will fit in that little circle. So no matter how tight I squeeze this, I cannot hurt the leg of the little hummingbird. So we'll go ahead and see if we can get that in there, maybe. Or maybe not. And the way the pressure is on there, that is, it keeps it at a position where it will easily go over the hummingbird's little leg on there. Now, we'll go out when we catch the hummingbirds, we use the little mesh bag and we'll put the little hummingbirds down in here. This way it's soft, they can breathe, they can hold on, and hummingbirds love to hold on to things. So there's a lot of little holes in this thing that they can hold on to. So now let's go outside and see if we can catch us a hummingbird to put a band on it. As we go outside, you're seeing some parts of our education center here with the Arkansas Game and Fish Commission. We're southeast of Little Rock. You know where Little Rock, Arkansas is. And as you can see, we got a lot of little eager hummingbirds hopefully wanting to get a little band on me. So I'm just going to reach in and see if we can find us a male.
Female.
Female?
You got one male in here,
Oh, great.
but either one. Here's our male right here. Oh, now he's gone. Now he's up.
I want to get a male so you can see the red throat on this.
We can see him pretty good from here, though. So anything's fine. Sometimes it gets kind of tricky.
Yeah, that's all right. We'll try this one. This is a little female. I don't see another. I'm not seeing the male from this side.
It's not banded yet, is it?
It is not.
How many recaptures do you typically get your return rate?
I have to look at my numbers for sure on this. We have a pretty good return, probably about 30 to 40%. And this was one of the reasons we wanted to start banding here. We're in a natural flyway for the hummingbirds. And so we wondered, do you get the same hummingbird come back to you? How long does it stay with you? And through banding, we can tell information like that. And we've had one little hummingbird, hummingbird that was hatched out here, and we checked him 11 times that summer. So we were pretty sure that he stayed with us all summer. The hummingbird programs that we normally do in our classroom, we have people come from all over the state and from other states sometimes. And although people love to watch hummingbirds, they don't ever get the chance to really be right close to them and learn a whole lot about them. They just think they're pretty. And so we try to give them a little bit of education about the hummingbirds, what they need to do for them, and a way to help them. Now, I'll put the little hummingbird in the little hose, and ladies, y'all recognize this, the little hose that we try on when we try on shoes. So I'm going to wrap this, put the little hummingbird in this, and wrap that around it. And little hummingbirds can be kind of sneaky. If they happen to see one little hole that they think they can get out, they're going to wiggle and try to get out of it. So this little girl is so far settling down. I want to be sure that I have a good hold of her before I come out of that net. And she says, hello. So give me a chance and I'll show you how I can fly. All right, let's get you wrapped up. And with this hose is real soft. Most of the time when you wrap this around them, they settle down. It's kind of like, I guess, swaddling a baby or holding a little kitten or a dog, a little puppy during a storm or something. But it kind of keeps them calm. And so that works pretty good for us. A band on the right leg. And let's be sure that we're seeing what we are doing. So here was our band. We're ready to go with that. And hummingbirds love to hold on to things, and they'll hold on to just about anything that they can get their little foot on. Remember, hummingbirds can't walk, but they have a pretty good grip that they can hold on to things. Hold on to a limb when they at night, when they go into torpor and go to kind of a hibernation. And we'll try to get her little foot open so I can get hold of it. I want to be sure that she is wrapped up. And all I want out of this hose, outside the wrapped part of the hose, is that little leg. So here's her little leg. And we'll slide the band right on there. Okay, she's part of the family now. She has her little number on there and all. Remember, it's a letter and 5 numbers. And first thing that I do always is check and be sure that band is okay. Be sure it rotates, because if I get to catch her again, I want to be able to rotate that band and be able to move it. And that looks like it's in good shape. Now we'll go ahead and start her measurements. So there's certain information that we want to get on her. We know this is a female. We know, of course, this time of year, all we have is after hatch birds. We don't have any just hatched birds right now, because these birds are just now coming in. So we know she's going to be an after hatch year. We know she's a ruby throat. And let's see how long her wing is. And so now all I want out is just a wing. And when we catch the little hummingbirds, sometimes they're ready to give us little presents here. So we'll get that out of the way. Okay. And now let's see if we can get her little wing out. And on us, this would be like measuring from the top of our shoulder to our fingertips. So I've got that out where I can get to it. And I'm going to go from the top of the shoulder. And I don't really want to touch her any more than I just barely touch the feathers. And get kind of an approximate length. Okay, 27.18. A little bit small, but and we'll get the tail measurements. And once again, this will involve having to be a little private here. Okay. She's got a nice long tail. The Coleman, or the little beak.
Your wing is actually about 42. It's your battery's low.
Right.
Your Coleman's going to be a little short too. Battery.
All right, let's see if we can get the Coleman or the little beak on her. Now she's got that little head out. She's looking around. She's trying to see where she might get to go. So we'll have to be real careful. This on us, this would be like measuring from the bridge of our nose to the tip of our nose. So 17. 17. I'm having to read the actual numbers on this. We had our little thing going all day today, so it's our measurements are. My battery's about to go down.
Wait.
All right, let's do the weight. Once again, we're going to wrap her up real good. And I also will hold my hand over that just in case she starts wiggling to try to get out of there. All right, 398.
And then show the tummy.
Now, hummingbirds have somewhere between 950 and 1,000 feathers on their little bodies. And but there's one place that they don't have feathers, and that would be on their breast area. And this, when I tell people that, they just look at me like, oh yeah, right, okay. So we're going to, we've got the breast area up for our little girl here. And I'm going to blow through my little straw very gently.
You can see that really good.
And see, I told you so. They don't have any feathers there. Probably the reason for this, hummingbirds do everything really, really fast. And so they want their little eggs to hatch real fast. A lot of birds will, when they're sitting on the nest, they're going to pluck the feathers on their chest area so they can have that warm skin contact with the egg. Well, the little hummingbird, her beak is, you know, if we were a hummingbird, her beak would be this long and it doesn't bend this way. So there's no way that she could pluck those herself. So God just didn't give her any. And that way she's got that nice warm body contact with the eggs and can get them incubated and out hatched and out on their way pretty well. The next part, when we have a group in here, I'll ask for a volunteer to go out and we'll put the little hummingbird in their hand and it will take off like that. So that's basically what we do as far as showing people you know, a hummingbird really, really close up on there. So we'll take her back outside.
And how long have you been banding?
I started banding hummingbirds in 2009. So we've banded several years. It's a fun thing to do. Yes, it's a fun thing, but just like all the presenters before us, you gain a lot of information about the hummingbirds. And basically what we're trying to do is educate the people in Arkansas as part of our goal and plan in the Game and Fish to help take care of the birds and animals and the vegetation in our state. So this helps educate the people on how to take care of their hummingbirds, what to plant, things like that.
And what's your main goal of banding? What are you trying to figure out?
Well, a couple of things. I want to know, do we have the same bird that comes back to us? And we do. We can prove this with banding. Does the bird hang around? Does it stay with you in the summertime? And when you check birds 2 or 3 times during the summertime, you can see that they are staying around there with you. So those are some of the main things that we wanted to find out. That was pretty well what we were aiming for, and we have been able to find that out and pass that information on.
Thank you so much, Tana. This has been excellent.
All right, I'm gonna let her go.
Here we go.
So I can show you that she is perfectly fine. And away she went.
All right.
Hey, and that's one of our major programs that we have here, and trying to tell everybody about hummingbirds and how they get here and why, hopefully why and how they stay. So thank you for having us, and y'all come see us here in Arkansas.
Oh, thank you, Tana. It's so great to visit with you again. We really appreciate your time and the excellent presentation. We've come a long way since virtual started, haven't we?
Oh, yes.
Yeah.
Yes. We really have. Yes.
All right. So thank you again.
Okay.
Live from Arkansas. Here we go. Now we're going to head off to California, and I'm
Right.
excited to have Lisa Tell join us. Lisa, I'm going to bring you on. Thank you so much. And thanks again, Tana. Lisa Tell is a researcher who does amazing work on hummingbirds, and she's going to talk with us today about some of her research and some of her work learning about the factors that threaten hummingbird populations. And maybe you can offer us some ideas about how we can help them, Lisa. I'm going to turn it over to you.
Okay, thanks very much, Susan. Can you hear me okay?
Yes, just fine.
Okay, great. And then also, if you let me know if my slides are advancing.
I will.
That would be great. Okay, let's go ahead and share this. Okay, are those advancing?
Yes.
Okay, perfect. Okay, great. Well, I'd really like to thank you for inviting me today. It's really an honor to be presenting. And I had meetings prior to this, but I was able to hear part of Christine's talk and then the wonderful demonstration right prior, which was really enjoyable to see. So thanks very much for that. All right, so today I'm going to be talking about some of the research highlights that have been ongoing at the UC Davis Hummingbird Health and Conservation Program. I'm a faculty member within the School of Veterinary Medicine, and I'm a veterinarian myself. And I've always been interested in bird health and populations. And given the dearth of information in regards to hummingbirds, that was one of the major goals for this program, was to identify some of the things that are a potential threat to hummingbirds, but also to establish some baseline information. So back in 2014, we did a survey and a review of the literature, and we looked at what had been reported and published in the literature in regards to any pathogens, whether they be bacterial, parasites, fungi, and disease conditions that have been reported in hummingbirds. And so we did a comprehensive review looking at that. And that gave us a baseline from where to go. So since then, what we've done is we have done a multitude of population health studies. And these are the ones that I'm going to be talking about briefly today. And we have others that we've done. We've looked at kind of the immune function also of birds, but this is just a short list of some of the things that we've done. And I'll go through the highlights of them in today's presentation. Christine actually did a great job for the insecticide exposure study, so I won't have to cover that one very much. And I appreciated her presentation. Okay, so we got a great demonstration about banding, and here at Davis, we also band birds, but we have gone towards some other ways of identifying individual birds and using some different technology. So we use radio frequency identification tags to allow us to do a lot of the same things that banding allows us to do, but this also allows us to expand the abilities of our being able to look at hummingbirds, how long they're at feeders, what kind of contact networks they have. And this technology was actually really, really helpful during COVID, when we were limited in our abilities to go out and trap and work with birds, and until we could get authorization to be able to do any research. So during that time, we were passively collecting data during the period of COVID, which was very, very helpful. Okay, so what we wanted to do with this study was we wanted to evaluate whether or not this RFID technology. So it's a passive way of gathering data. We didn't have to go out and actually capture the birds and look for recaptures. Now, we did have to go out and capture the birds to initially tag them. But then after that, if they stayed in the area and they went anywhere near the antenna, we were able to detect them. So we wanted to look at that technology to see if we could gather data to look at methods where we could study disease transmission, especially in urbanized hummingbird settings. So what we used was these passive integrated transponders. They're called PIT tags. And they're 8mm full duplex tags. And what we did was we went ahead and placed these under the skin on the back of hummingbirds. And that was the way that we were able to get information in regards to the presence or absence of a bird at a feeder. So initially, when I started out doing this, I had a system that was designed so that what had to happen was the birds would fly in through an antenna here. And since, as we all know, hummingbirds tend to fly up, what I did was, it was almost kind of a modification of what you would think of as like a feeder hall trap. Was at the top, there was an opening also, so that when the bird would fly in, it would go ahead and consume some sugar water at the feeder. And then after it was done, it would fly up. Now, we had antennas both in the entrance and in the exit, and we soon learned that we didn't need antennas in both locations. But this was a way for us to be able to detect birds at the feeders. Now, interestingly enough, it took a little while to train the birds. At first, I started with Anna's, and they were a little bit shy of the system, but it was interesting because as soon as the rufous started migrating through our area, once the Annas saw the rufous go in, the Annas went in right away afterwards. And it didn't take very long for us to get the birds habituated to using this system. Now I use the system without any of the netting, and the antenna is actually just placed underneath the feeder in close proximity to the feeder. And that's been helpful. Okay, so this is a video, and I'll just play it back. So this is a location, one of our study sites in Southern California, and this is the antenna here, and the birds fly in, and this is the feeder. In the bottom, it's a grate system so that we can open the bottom. We can also wash it, and we can use the bottom area to introduce the feeder once it's refilled. We've developed a different system now where we, if we have any of these systems, what we do is we just have a linear hole here in this area, which allows us to reintroduce the feeder once the feeder's refilled. Okay, so this is what it looks like inside. So as that bird comes in, a tag is read. And then you have more birds coming in, and each time they come in, the tag is read. Okay. So then what we get is we get data. There's a reader that is connected to the antenna, and then you get data that's in this format. It tells us the date, the time, the location of the tag reader, the actual tag. This is the actual tag. And then it gives us latitude and longitude coordinates. We actually have the readers programmed in a specific way, because if you do continuous reading, you just get a ton of data. So what we do is we have the readers programmed so that they read a tag from one bird. So if the bird stays at the feeder continuously, it reads its tag every 10 seconds. Okay, so this was our initial data, and we have a lot more data now in 2021, and we'll be doing a 5-year review of this. But when we looked at September 16th through March 2018, we had 175 hummingbirds, and we had 117,000 reads. Currently, we have probably close to 800 or 900 hummingbirds tagged, and we have over 1 million reads. The percentage of birds with at least one tag read was about 69%. So a lot of birds had at least one tag read. the time in which the birds were detected with the antenna after tagging, there was a pretty big range. So some birds came back right away and some birds left, and we didn't see them again until 444 days later. Now, when we first started this, at the location where we were working, we did not have all of the feeders equipped with antennas. We only had one feeder equipped with an antenna. And now we have all of the feeders equipped with antennas and readers. So that might have changed if we had all of them equipped. We also were able to look at the total amount of time that the birds were spending at the feeders, and then the time spent per visit. And so that was a lot of data that we were able to record. The other thing that we were really interested in, and this is why we did this study, is because we're interested in looking at certain diseases, and we're looking at contact networks. So which birds are coming in contact or close proximity with other birds, how long they're staying, what the interactions are. And so with this data, what we were able to do is at all of our 3 different locations where we were gathering data, is we were able to gather data about individual birds. So this female, the wider the circle, the more time they had contact with other birds. So the males here have a lot of contact with other birds, and especially other males. But interestingly enough, we had some females that actually had a fair amount of contact with other birds, whether they be males or females. So these are birds that stayed and didn't fly off, and stayed and had more contact time. So that study is important because one of the diseases that we're looking at is the viral disease hummingbird pox. And so that's why we were interested in establishing that contact network information. Okay, another study that we did was looking at histopathologic findings. So we took hummingbirds that died in rehabilitation centers. So we didn't sacrifice any birds for this study, but birds that died in rehabilitation centers, we went ahead and looked at why they were dying. And so what we did was we took their tissues and we fixed them, and then we looked at them under a microscope to determine what the cause of death was. So we had 61 hummingbirds. Like I said, they were found dead or discovered in a moribund state. Some of them came from the San Diego Zoo, where they were, like I said, found dead or discovered in a moribund state. And then the Rehabilitation Center, Lindsay Wildlife Experience, any of their birds that died during rehabilitation, they went ahead and processed those birds so that we could examine them. So the thing that we found of those 61 birds, the one thing to highlight is 23% of those birds looked like they had pretty significant injury due to trauma. So that was 14 out of 61. Then there were other reasons like infectious diseases. So that's going to be your bacteria or your viral or your fungal infections. Some of them had parasites. Some of them weren't in good body condition. Typically, most of the birds that we see, especially the migrating birds, are in good body condition. They have to be able to migrate. And then a lot of them had more than one process going on. The other thing that was highlighted is that if you look at those 61 birds, a lot of them had parasitic infections. So 13 out of 61. And there's a worm, it's the tapeworm, that seems to be infecting hummingbirds. And so we're doing further work looking at that. Okay, so following up to parasitic infections, one of the studies that we did was hummingbirds have a mite, and it's on the feathers of typically their tail is the most common thing, not very common on their wing. And so this mite that's in the genus Proctophyloides, we were interested in evaluating that and trying to figure out the pathogenicity of the mite and a little bit about the behavior of the mite. So these are not the flower mites. These are actually mites that are on the feathers. So they're feather mites. So what we did was we first tried to use regular electron microscopy and traditional EM, you actually have to coat the feather and the mite using a metal, it's typically gold. And that's challenging because you desiccate the mite and you displace the mite. So what I ended up doing was getting access to this tabletop scanning electron microscope, and it essentially looks like a computer. And anyone who knows anything about electron microscopes, this is incredibly small. But the cool thing about it was we were actually able to go ahead and take feathers from a bird and go ahead and image the mites live. So we could see the mites, we could see the orientation of the mites. So these are all young mites. These are adult mites. These are adult mites copulating. And we were able to see all their positions and how they lined up in the feathers. And it was really interesting. Okay, another study that we've been working on is looking at pox. That's a disease that has really high visibility, especially for people who have feeders in their backyard. It's a virus that's related to smallpox. It has a vector, so it has typically an insect vector because it has to complete its replication cycle in a non-avian species. It is a virus that can withstand extreme dryness, and it's pretty common in warm and humid environments. And that's typically because of the insect host, which is most commonly a mosquito. And this is classified as an emerging viral disease according to the US Geological Survey. So what we wanted to do was we wanted to look at the type of samples that could be used to diagnose pox in a live bird. Typically what you have to do is you have to take a tissue sample and you have to, so it's a tissue biopsy, and you have to look at it under the microscope. But we wanted to see if there was a better way to do it more in a more gentle manner, non-invasive manner. So that's one of the things we wanted to look at. We wanted to look at how the pox in hummingbirds compares to pox that are found in other birds, prevalence of the disease. So we wanted to look at how often this disease is seen in hummingbirds and in different species of hummingbirds, males versus females. We're interested in looking at what vectors the disease, so what insect is transmitting the disease from hummingbird to hummingbird, and if climate change is going to impact this disease in hummingbirds. So the exciting thing about this study was that we were able, so the classic is going to be tissue, where in 100 samples tested, we got 97 of them positive. But we also discovered that it wasn't quite as high of a positivity rate, but we could actually use feathers, tail feathers and body feathers for diagnosing this disease in hummingbirds. And this actually applies to other birds. And so this is a disease that infects a lot of birds, and this makes it so that investigators can get some kind of an idea as to whether or not a bird might be positive for pox without actually having to go out and take a tissue biopsy. So that was a major finding. Okay, the other thing we did was we looked at, another study that we did was we were looking at admission trends for hummingbirds in California-based rehabilitation centers. We looked over a period of 26 years. So the data came in through a database that a lot of rehabilitation centers use, and we had a variety of rehabilitation centers that participated. They were 3 wildlife centers encompassing 192 cities, and we had close to 7,000 hummingbirds. So what we did was we looked at the trends depending on the different rehabilitation centers. And then we also looked at kind of the distribution geographically of the presented hummingbirds and tried to get a sense of what birds were coming in and what the trends were. So reasons they came in, found on the ground was the most common reason. Found inside was another reason. A bird hitting a window or glass door. Found in a torpor-like state. We had 222 birds that people brought them in because they were found in a torpor-like state during the day. And then a lot of birds nest related, 873. And then also a good number of birds that were found by domestic animal. Most of them were cats. There was 1 dog and 1 chicken. Okay, and then we had an unknown percentage. So we looked at the probability of release based on some model results, and I'm not going to go through all these details in the interest of time, but essentially we kind of looked at what the trends were when the animals came in and what the highest likelihood for them to be able to be released. There was definitely seasonal things that increased their likelihood of being released. If they got sugar water, that was certainly helpful. And then the other thing that was helpful for the trend of release is those young birds, like the nestlings. They were most commonly the most common group to be released successfully. Okay, so just briefly also covering some baseline information that we've been getting. We've been looking at trace element contamination and feather and tissue samples. So once again, you'll see this theme of using feathers, trying to minimize the impact on the birds, but be able to sample and assess diseases or like heavy metal exposure. The tissue samples that we used, once again, were from rehabilitated birds that died. And we went ahead and assessed what was normal for hummingbirds in regards to trace elements. I'm not going to talk about the neonicotinoids because Christine already did a great job with that. We did another study where we looked at, so it's essentially microbial community. So we were looking at bacteria and hummingbird feeders and fungi, and we were trying to assess them compared to floral nectar and how it was influenced by bird visitation. And so in this study, we found that flowers and feeders, not surprisingly, they had different distinct bacteria and fungal communities. So the feeders had very different populations of bacteria compared to the flowers. The flowers had mostly this one group of bacteria called Proteobacteria, versus the feeders had a variety of bacteria. Now, most of them were not ones that we consider pathogenic, so ones that we find in lesions in birds or cause systemic disease, but that's to kind of be studied further because they're non-pathogenic from the standpoint that they don't cause really severe overt disease, but they could potentially have impacts on the normal flora of hummingbirds and might cause what we call some GI disruption or GI bacterial dysbiosis. So we know that by providing sugar water, the human provisioning of sugar water, it does seem to influence the bacteria that hummingbirds are consuming, but we don't yet know how that impacts their health. Okay, the last study just that I wanted to briefly talk about today was we're doing a study here in California looking at Anna's hummingbirds, and we're looking at the genetic diversity for different populations. So this is called the Genoscape project. We selected specific areas to go ahead and sample Anna's hummingbirds in particular. And we went ahead and used a variety of different samples. And from this, we were looking at genetic diversity. And for the most part, most of the hummingbird populations for Anna's across the state of California where we sampled were actually, there wasn't a lot of genetic diversity within them. Okay, I wanted to highlight, we just published this monograph. It's with the Texas Tech University. And if you go to their website, you can actually download this for free. You'll go to the Natural Science Research Laboratory. We did a monograph on looking at hummingbird research. And what we did was we basically did our literature review, but we also talked about welfare conscious study techniques to think about when you're working with live hummingbirds, and also for the means of processing hummingbird specimens. So we talked about permits, working with hummingbirds, all the different kinds of sampling you can do, euthanasia guidelines in the case where there's an unfortunate case where you have to euthanize a bird. Post-mortem examination. This is the type of examination that needs to be done if you're going to determine why a bird dies. And you can't freeze a bird, unfortunately, if it dies and then get a good post-mortem examination to figure out why it dies. You have to preserve it specially. And then field collection and sampling. Lastly, we worked with the design program at UC Davis, the students in the design program, and Marla Greenway was an undergraduate student who got a minor in writing. And so we also went ahead and did this book called If Hummingbirds Could Hum. And it was really a fun project. And one of the things that's in there is a flow diagram that tries to advise people what to do if they find young hummingbirds or they see a nest, kind of what some of the approaches that they can take in regards to what to do with those young birds. Okay, so that's it. Thanks again to Susan and her team for inviting me to go ahead and present today. And it's really a privilege to be here.
Oh, it's a privilege to have you. This has been such an amazing group of people presenting today. Every presentation has been excellent with so much information. So thank you so much, Lisa. I'm just going to do one question because we're trying to catch up a little bit on our time. One thing that people may not realize or not know how to handle are those window collisions. And I think when people see hummingbirds are so impacted by windows, they're maybe surprised because I think we think of bigger birds. I don't know why. Can you speak to that a little bit and make suggestions for how people can help at home?
Yeah, so I think, yeah, it is interesting because there are some actually really good guidelines for that, and especially for buildings. We actually had a building here in Sacramento area that we called, sadly, the death building. And it was a mirrored building and there was an oak tree. And unfortunately, what was happening was the birds were seeing the oak trees at a distance mirrored, and they thought they were flying to another oak tree. And as those oaks have grown and extended and gotten closer to the building, the birds don't seem to get up, just seem to be able to get up enough speed to be able to hit that building as hard. And so we were having less deaths. So, a lot of things that we try to advise people is using decals and things like that. There are some specific decals that you can use on your windows to try to reduce the collision with windows and doors. The other thing that we recommend is really knowing when certain species come through that are a lot more aggressive compared to the population that is currently resident in your area. So when the rufous come through, I'm really very careful to advise people to think about how your feeders are placed so that when another hummingbird is being chased, it can't get up enough speed to hit the window. So what we recommend is that you have the feeders way far away from the windows and try to minimize the impact that the birds would have. So really being aware of where you might be having hits and trying to use mechanical means maybe to minimize those, or once again, if you have feeders, change your feeder strategy, or even how you plant.
Mm-hmm. Thank you so much. If we think about that, if every home did that, then we would save so many birds.
Yeah. All right.
Thank
Thanks
you,
very
Lisa.
much.
We appreciate your time. And now we are going to go to Mexico, and Saraí Contreras and Fabiola Castillo are with us to talk about fire and hummingbirds. Thank you, Saraí. Again, Saraí and Fabiola will be presenting in Spanish. You can use the interpretation in the Zoom or go to birddaylive.com if you need English. Thank you for joining us today, Saraí, from the University of Guadalajara, but in the Cuxor campus in Outland, Mexico. Thank you.
Hola, buenas tardes. Muchas gracias por invitarnos.
Hello, good afternoon. Thank you so much for inviting us.
Yo soy Fabiola Castillo.
My name is Fabiola Castillo, and I am working in collaboration with Saraí in a project that is related to the fire and hummingbirds. In this work, we are participating with the local communities and with people that work with the federal government in protected areas, also with staff from the university, students and other colleagues, research colleagues, and also with people that are part of international institutions, like Susan. And what brings us here today are forest fires. But specifically forest fires. I think we all know that forest fires are present here in Mexico. We are going through the fire season in the United States as well. There are many fires there have been a lot of fires from January to April. We've had way more fires than the same period last year, and last year was one of the worst forest fire seasons in Mexico. In Mexico, there was a day in which we have 118 fires at the same time, and now we have more. And in the same period from January to April last year, and this year we have 4,676 so far. We can see in the graph from 1991 to up to 2021. And we have fire seasons that are more intense than others, but the fact is that the fire statistics end up being the same in different parts of the world. They continue to rise, they continue to affect a bigger area, and they become more frequent. For Mexico, fire risk is related to agriculture activities and livestock activities, along with other production activities. But the danger of the fires is related to fuels, and fuels are available when there is too much productivity, when there are high temperatures and low levels of humidity. So in order for a forest to burn, there needs to be an interaction with the weather. So there is something that is very worrisome, which is global warming, and it is definitely influencing the fire activity. So a fire occurrence and climate change have a back and forth relationship. Higher temperatures creates a higher amount of fuels. The burnt areas become bigger. The fuels are more available. If they were not before, they are now. So emissions increase. A higher level of emissions means a higher level of carbon, which increases the global warming and increases the temperature. And so that's how our forest fires incidency starts to increase. And under that context, we understand that fire needs to be managed. So how can we manage that? Well, we need to understand what is the effect of the fires and what is the effect, how it varies in space and time, and the succession in the forest as well as in landscapes, considering that the biota is adapted to the fire. So as an example, we have this graph from NASA where we have the influence of fire from millions of years ago. We have the influence of fire, but with human activities, there is way more fires. And with climate change, the rate continues to increase. So a way of taking care of this is fire ecology. And this is based on a triangle, which is about understanding fire behavior, understanding the ecosystem's response through to the periodic incidence of fires that is known as fire regime. So the first is the fire behavior. What is the necessary weather or climate that we need for a fire to happen? What are the conditions of topography and what amount of fuels do we need to have a forest fire, and how much of that fuel is produced? In Mexico, we have temperatures that go over 28 degrees Celsius. We have humidity that goes below 30% during fire season. We have slow winds, but with a higher rate of winds between February and January. Usually there is no rain during fire season, except in very specific areas. And we have a mountain system, which is the Sierra Madre, and we have volcanoes and mountains with altitudes up to 30% that make fires more intense. And regarding height is from sea level to 4,000 meters over the sea level. And When the mountain is facing north, I'm sorry, to the south, it tends to be warmer than when the mountain is facing north, where the area is a little colder. And so this has consequences in the vegetation. We have pine forests mixed with other conifers on the highest parts of the mountains. So we have pine forests that are mixed with broad-leaved and membrane and sclerophyll on mid and low elevations. Frequently, the forest is also mixed with grasslands and shrubs, and especially when they're near agriculture and cattle ranching areas. And frequent fires are supposed to have a low fuel loads, but in places like the western part of Mexico, we have a high productivity due to the coordinates where we are located, which means that we have enough fuel loads to continue to produce fires. So on the side of the ecosystem response, we need to understand how the ecosystem responds immediately after the fire starts, including death or survival of the organisms. The organisms that do survive, they survive either as a species or individuals. And that is at a short term or right after the fire. But it is important to also consider the period in between fires, which are the species that can regenerate, which ones are the ones that have to compete, and which ones have the ability to tolerate. The response of the ecosystem depends on the adaptation attribute of the selective environment that the organisms have. Fire is known as a selective force. The frequency, severity, size, and seasonality of the fires, of frequent fires, and the severity on which they affect environmental attributes like soil, air, water, or the amount of radiation after the fire. So we can see that the weather interacts with the fire and with the topography and with the soil characteristics to determine the response of the ecosystems. In our case, in the Biosphere Reserve of Manantlan, we have pine forests that are about 15 years old. So what happens? Sorry, we have an interval of fires of every 15 years. And so what happens? After the fire, the shrubs regenerate through seeds. The gaps created by the fires remain open for 5 to 7 years until the trees replace and establish herbs and shrubs. The fire season ends when the rainy season begins. And so when the rains come, herbs and shrubs start to bloom, and those that reproduce or breed start to do it faster, which means that we see flowers blooming that become resources for the animals. After 15 years, the tree community closes the gap and so changes the community in the understory. The other thing is the fire regime, and this is the variations in the frequency, the return interval, intensity, severity, size, seasonality, and synergies that include other human activities. In this case, for our country, we have a study in which we've classified the fire regime depending on the conditions. And the area in which we work, which is the western part of Mexico, where we have low severity but frequent fires. The fire regime does not happen homogeneously. There are places that burn this year, other places that burned last year, and so. So this pattern is heterogeneous, and we have mosaics of fire collisions. So we have different ecosystem responses and different impacts and effects. We can find them in the landscape because the conditions of the vegetation are different, and these different conditions change over time and change in space. So the factors that influence this mosaic in the landscape after a fire depends on the previous story of disturbance, the renovation, the growth, and the conservation of the ecosystem, and the changes that could happen over time or in space after the disturbance. When the regeneration happens, the growth happens uh, in a cycle. In the case of Las Joyas, which is a research station in the Manantial biosphere, we can find mosaic in different stages. For example, we have mixed conifer, broadleaves, or mesophyll, or shrubs that over time grow, and then there's another disturbance, and how we manage these areas includes prescribed logging or timber collection, timber harvesting, sorry, and other practices to manage the forest. Thank you so much, Fabi. Well, now we've heard Fabi, and this information about fire ecology has been used to study the secondary effects that forest fires have in the hummingbird communities. We have 24 species present in the Manantial biosphere, which are distributed in a height gradient that goes from 400 meters over the sea level up to 2,800 meters over the sea level with different types of vegetation. So what we have done in the last 30 years is trying to understand the effect that these fires have that Fabi just described. And we've understood how the community of hummingbirds react to these disturbances. And we have different effects that go through a successional process. The first years after a fire, we're going to see populations, or rather species. For example, migrant species like the rufous hummingbird, like the Calliope hummingbird, they respond in a positive way due to the conditions left by the forest fire. When the ecological succession continues after 17 years, we see that the populations of these hummingbirds start to decrease, but the population of local or endemic hummingbirds start to grow. So this is a very important thing to understand, because in order to keep the biodiversity of the 24 species that correspond to the region, we need a mosaic like the one that my colleague was mentioning, a mosaic of different stages after the forest fire. And for that reason, we decided the rufous hummingbirds because of the way it responds to fire. In other presentations, we understood that it seems that the rufous hummingbird has recently started to decline. About 60% of its population has decreased. So in this graph, we can get to know the state of knowledge on conservation of the rufous hummingbird. And we see that we still need to understand a lot of the processes in order to increase the level of conservation for these species in everywhere they are present. And at a very local level, I can tell you that we have studied the rufous hummingbird throughout these 30 years and changes in space and time. So this is just a very small example when a fire happens like the one that happened in 1983. There was a canopy fire that devastated a lot of the trees. And then over time, it started to recover, like you can see in the pictures on the right. So look, afterwards, in 2012, we have a young forest that is already covering the gap left by the fire. We can also trace that thanks to capturing rufous hummingbirds. And so we realized that after a very abundant fire, as years go by, and like Fabi mentioned, the natural return of fires in this area is a gap, an interval of 15 years. So imagine that between 15 and 20 years, the Rufus hummingbirds is no longer there. And this is related to the relationship that Fabiola was mentioning about having a bigger understory, then there is a less number of Rufus hummingbirds because the food is no longer available just for them. And with very easy data that I'm going to show you here, but knowing the genealogy of when they arrive, when they leave, of each of the species that we have. For example, we have the Rufus, the broadtail, the Calliope, Ruby, Allen, Costas, Black-chinned. We have understood very well the phenology, but we also know the level of fidelity that they have to the site, the level of survival, the rate of survival. And these are very easy results as well. For example, from October to March, we see that every 2 weeks, the Rufus hummingbirds and most migrant hummingbirds of long distance, they come here or they arrive molting, already molting or beginning to molt, and they molt throughout the winter. So they're molting their feathers all that time. So we need to offer them the right amount of resources so they can recover the energy that they need to create new feathers. And so we created a molting model for them. We know that the younger birds and also the adults start their molting and the molting in their bodies when they are migrating. And when they arrive, their rectrices are starting to molt. And here they complete their molting process in order to return to their breeding season with completely new feathers. These models have allowed us to integrate them in the management of the area and what is called prescribed burns. Sorry, directed burns. So this process of knowing when they start molting and when they finish let us know when we have a window to implement the guided burns and not when the government decides, which is usually based on the budget because they want the lesser risk, for example, or they think that there is a lesser risk in December or November, but that's not the case. We've already experimented that because, for example, the salvia does not regenerate if we burn it on November or December. And so we also need to study the flowers abundance. This has been studied throughout the years since the 80s, and there has been different studies coming out in 2015, in 2017, and there's another coming up. We see that there is a dynamic that is very changing, and we see that flowers are going to regenerate depending on the conditions of each side, depending on the season that they are. So what's fascinating about this is that throughout the migrant season, we are going to have some level of abundance of different species of flowers until they leave, even for resident or local species. And I have to specify that it's resident species also because people from the US and Canada are listening to us. So all of this knowledge has allowed us to implement the restoration of habitats for hummingbirds, specifically within the biosphere in coordination with the CONAP and other institutions, because the idea is that with the knowledge that we have about forest fires in this region is to diminish the impact or rather the threat because we are having more and more fires. And the other thing is that we also need to keep the different seasonal states that of the forest fire interval so we can have a more quantity of biodiversity in the area. This experience was taken to or was scaled up through partners in flight so we can be able of understanding the whole life cycle, not only of the hummingbirds, but of many other species that we do have in the west part of Mexico that are long distance migrants that are endemic to the place. And as you can see, this blue this blue area shows us that this is the area where they overlap, which is also the area in which we have the highest incidence of forest fires. And we've also seen that in North America, over 3,000 million birds have disappeared, which means that common species are not as common as they were before. This is a very big alert. And so different institutions in the western part of Northern America and Mexico are trying to face these threats. And we want to scale it to a continental level. That's why I want to show you this map about the planning strategy that we have thanks to the Western Hummingbird Partnership. Thanks to all of these institutions that you can see here in the map, we have actions, especially in this area, where we have 7 species specifically that travel long distance. And most of them stay for many months, from 7 to 8 months of each year here, so they can continue to survive. And well, related to this, I can also tell you that we've carried out local festivities. I don't have the announcement right here, but I'm going to leave you a link of YouTube here on the slide if you want to get to know more about these initiatives. This is a video that is very interesting that talks a little bit about the experience, and we are about to move on and continue to collaborate at all levels. So thank you so much. And now we are ready for your questions.
Thank you so much, Sarah and Viola. That was excellent. Someone is asking if we are recording the sessions, and yes, we are definitely recording the sessions. So if you want to go back to these sessions, you can watch them later. We'll be putting them up on, they'll be up on our Facebook Live page at Environment for the Americas and other locations too, but we'll let you know where they are. So thank you so much, Sarayi and Fabiola. That's an incredible amount of work that you've been doing. And in terms of questions, we have a question from someone who wants to know about using the fire to create these openings. How will this method be used elsewhere in Mexico? And is it important in other locations in Mexico?
¿La puedes traducir, por favor?
La pregunta es que para hacer las áreas abiertas en...
So repeating the question in Spanish now is a question to... We understand that keeping the gaps open it's important for the hummingbirds, but is it important also for in other places for hummingbirds or only at the biosphere?
Es una pregunta muy interesante porque lo hemos visto.
Well, that is a very interesting question because we have seen this in other places, not only in the biosphere reserve. We have conditions also in the forests in Sinaloa, for example. And we've also seen literature that talks about the relationship between the rufous hummingbird and the forest fires. And I think it is important not only for this reserve, I think it's important to have this type of prescribed fires that Fabi mentioned, that is not any type of forest fire that is going to, for example, huge forest fires that we have sometimes, they're not helpful because not all of them are going to allow flowers to grow. Fabi, I don't know if you want to continue. Yes, it's important to keep a fire regime in the area. If the area has been historically burned in a certain way with certain force, and we are able to foresee it somehow, that's what we want to simulate through fire management. So if there are hummingbirds present in other areas that respond to the same fire conditions, then it's important to create these gaps in the forest to be able to favor the resource that they need. For example, we've calculated here that between 1 and 3 hectares of an opening is very helpful for an area of 50 hectares of forest. So this is something that we can keep. Well, of course, we need to have the seasonal states and all of that, and it's not easy, but it is possible. Thank you. And there is another question, which is after
sus estudios, van a
after you finish your study, are you going to share the information for other reserves or natural places in which they need the information to continue the conservation of hummingbirds? Yes, actually, we are making a conservation plan for the western area of the Americas for hummingbirds specifically, and we're about to finish the monitoring part, which Susan is not going to let us lie. This is something that we want to finish and we want to do. We hope to do it by the end of the year to have the management plan, the forest management plan for protected areas.
Presenters today for this special session. Again, this is part of a series of sessions that we're offering through the Western Hummingbird Partnership. This one is also in celebration of World Migratory Bird Day, raising awareness about hummingbirds and the need for conservation efforts to help protect them. So thanks to all of our speakers today, and we look forward to working with you more in the future.